Hi Venkat, good morning.
Good morning, everyone. Welcome to day 2 of this program. We'll wait a couple of minutes for others to join in.
Hi team, good morning. Hey Venkat, morning.
Good morning. All right. While others are joining in, let us do a quick recap of what we have discussed until now. Before I get started, can you please confirm whether you can hear me loud and clear without any disturbance, and you can see my screen as well?
Yes, we can.
Yes. Okay. Yesterday we started with some Python basic commands and basic packages. Then we went on to discuss some basic statistics, basic stats, mean, median, variance, standard deviation, outlier detection, data exploration, validation, and cleaning. Then we went on to discuss regression analysis. Regression is the first machine learning model that is used for prediction. If we want to predict the target variable y based on x1, x2, and so on several variables, then this will be the regression line that we will be building. But we discussed something. Model building is only half of the job. Immediately after model building, as a good data scientist, what is our immediate job? What we should do? Right after model building, we perform the model validation. What is the model validation measure in linear regression? The model validation measure in linear regression. How do you validate whether the model is good or not? The model validation measure is R-squared value.
Yeah,
When do you say I have a good model? You look at the R-square value, and in which scenario you say that yes, I have a decent model, I can proceed with the predictions and all that. And the R-squared value is above 80%, isn't it? Above 80%, above 0.8. Sometimes your model will pass this R-squared value test. However, your model still may be suffering. Sometimes this R-squared value is deceptive. In that case, immediately after looking at R-square, what is the next measure I should look at? Immediately after looking at R-square, we are supposed to look at the adjusted R-squared. And what is a good value of adjusted R-square? What should be the value of adjusted R-square? The adjusted R-square value should be almost equal to R-squared value, nearby R-squared value. After this, what is the next step that we are going to take? You have used several variables. You have got a good model by now. Does that mean all the variables deserve to be in the model? Not necessarily. We are going to check whether the individual variables are impactful or not. X versus Y, whether they are impactful or not, each of these variables. How do you get to know whether a variable is impactful or not? You can look at the p-value. And what are the limits that we pick and choose the variables? What are the general industry standards? If the p-value is less than 0.05, such variable is impactful or not impactful? Such variables are impactful. We should keep such variables. The p-value is greater than or equal to 0.05. Such variables are not impactful. We can drop such variables. Okay. After that, we started a particular topic, then we stopped. What we will do is, until here, we'll execute it once. Then the topic of multicollinearity, we will freshly start. We will observe what is multicollinearity. Then we will try to see the treatment of multicollinearity, etc., etc. What I want you to do right now is go back to our Google Classroom, classwork, etc., etc. Finally, go into the regression file. This is the code file that I'm pasting. In the chat window, you can see the code file link. What you need to do is you go to a place where we have discussed adjusted R-square or multiple regression issues. Click on this particular cell, regional sales importing. Look at this. Go to this particular cell, runtime, run before. What this will do is all the cells before this cell will be executed. Otherwise, one by one cell, you can execute until here. Otherwise, you can go to runtime. You select a particular cell, runtime, run before. What this will do is all the cells that are there before this cell will be executed. And we will stop at this particular point where we have multiple regression issues. So stop at this particular point. Until here you execute everything. Once you are done with it, send me a message, then we will freshly start today. Let's wait for others to quickly confirm that. Once you're done until that point, send me a message. If everyone is done, we will proceed with the new discussion. A lot of people are still doing it. Just make sure that all of us are done, then we will proceed, okay? Are you facing any issues? Others who are still doing it, is there any error or any issues that you are facing in accessing the file or anything?
Venkat, right click and do it, or
So you have to go here and runtime is there, right? Runtime, runtime,
yeah,
run before.
okay.
So you have to select a particular cell which is down below multiple regression issues, which means that basically we are trying to tell Python that run all the cells before this particular cell. Runtime run before is one of the option. Run all is another option. Run after is another option. All right. Looks like everyone is done. So yesterday we discussed a particular issue in linear regression, especially when you are building multiple linear regression, which means multiple features are used. So go ahead, import that regional sales data, build the first model. This is our first model. In model 1, we have observed these results. Overall, the model seems to be good. Adjusted R square is near to R square. At this level, the model is good. Overall level, the model is good. Average income, average expenses, percentage male, percentage female were used. Out of them, looks like average expenses is not impactful. And average expenses has a negative coefficient. If at all, if it is impactful, it is negatively impactful. When we submitted this result to client, the client told us that average expenses must be impactful. This is one of the most impactful variable. Sometimes we do see these kind of discrepancies. Business logic tells us something, data gives us something else. There must be something wrong. So we have to investigate that. Average expenses should not have any negative coefficient, because as expenses increase, then sales increase. In a region, sales increase only when the expenses are high. If the expenses are low in a region, the sales must be low. So it has to have a direct relationship. But here we have a negative coefficient, which means that there is something wrong. As the part of investigation, what we have done is we have rebuilt this model, but this time we have built this model by dropping average income, by only taking three variables: average expenses, percentage male, percentage female. Overall model looks the same. Overall prediction level, there are no major changes, but one monumental change we have observed. The p-value, based on the p-value, we can say average expenses is impactful now. and average expenses has a positive impact. So in model 1, if we see expenses versus sales, expenses is not impactful. That was the first conclusion. If at all, if it is impactful, it is negative impact. So that means inverse relation. In model 2, the same expenses, same data versus same sales data. Here we are saying impactful and we are saying direct relation, which means as expenses increase, sales increase. These two are absolutely contradictory results. These kind of contradictory results happen if there is any interdependency between the features. If there is any interdependency between the features, we cannot really trust the beta coefficients. That will lead to these kind of wrong conclusions, these kind of contradictory results. This particular issue is known as the problem of multicollinearity. Multicollinearity means interdependency between the features. When you are building a model y versus x1, x2, x3 and so on, k features if you are using, the interdependency between the features is known as multicollinearity. Some of the examples are, if you take income as one feature, if you take expenses as another feature, these two are related to each other. If you take percentage of male, percentage of female, those are related to each other. In real world, definitely there will be so many variables that are related to each other that will lead to multicollinearity. Multicollinearity is not just the relation between two variables. Sometimes one variable is related to maybe 3 or 4 more variables. Okay, so that is also multicollinearity. Interdependency between the predictor variables is known as multicollinearity. Now I'm going to tell you how to detect multicollinearity, because you can obviously expect a lot of features. How do you detect whether there is any interdependency or not? Here is the process, all of you. This is the new topic. Now the new concepts have started. Look at this. The target variable y can be ignored when you are detecting multicollinearity. The reason is multicollinearity is a phenomenon that is related to only features. For some time, ignore the target variable, take the data of all the features. That's the first point. The second point is, take the first variable x1, consider that as target. Build a model by using x2, x3, x4 and so on xk. Use rest all variables, try to predict x1. Okay. Imagine when you built this model, imagine your R square value is around 95%. When you have built a model to predict x1 using rest all variables, you got the R square value. Let me call it as R1 square, because we should not confuse this R square with the overall model R square. This is a kind of intermediate model where I have used rest all variables for the prediction of the target here. R square value, R1 square is 95%. What does that tell you? Think about it. What does this mean? I have tried predicting x1 using rest all variables and I got the R square value to be how much? 95%. What does that mean? What does that tell you? What do you understand from there? Think about it. When you tried predicting x1 using rest all variables, you got a pretty good model, which means the information present in x1 can be easily predicted by rest all variables, isn't it? This model is good, not about the overall model. What is a model for us? Overall model is what? Y versus this one. Here this model is good, which means this model. So we cannot, like generally when we refer to model, we tend to refer to the overall model. But here this is x1 versus rest all variables. For this model, we got an R square of 95%, which means using rest all variables, I can easily predict x1. Is it a clear case of multicollinearity? Multicollinearity exists. Do you agree with that point? x1 can be easily predicted by rest all variables. Looks like there is some duplication of information. Whatever information x1 contains can be easily predicted with rest all variables. If you have these variables, x1 is redundant. You don't really need it. That is scenario 1. In scenario 2, when you built x1 versus rest all variable, let us suppose you got the r square value. Let me call that as r1 square for this model to be only 10%. For the same model in a different scenario, x1 versus rest all variables, you got the r square value to be only 10%. What does that tell you? What do you understand from there? When you tried predicting x1 using rest all variables, you got r square value to be 10% only. What does that tell you? It tells me that other variables cannot predict x1, isn't it? All these variables put together cannot predict x1, which means x1 carries some independent information that cannot be seen in the rest of the variables. x1 is independent of all the other variables, so there is no multicollinearity. x1 carries some information that cannot be seen anywhere else. That's why I have a poor r square for this particular model. x1 is independent. It should be kept in the model. That is the story of x1. What we need to do is take variable x2, build a model, x2 versus rest all, x1, x3, x4, and so on, xk. Look at the r square. Let me call that as r2 square. Take x3 versus rest all, x1, x2, x4, and so on, xk. Look at the r square. Let me call that as r3 square. And so on until the last variable, xk. Obviously, we are going to write a function which will take care of it. Xk versus rest all variables, x1, x2, x3, and so on, xk minus 1. Look at the rk square. For every variable, use rest all variables for predicting that particular variable. Look at this, any general, let's say any general ri square for any variable xi, for a variable xi, look at its ri square xi. Using rest all variables, you try to predict xi. Okay. If that value is high, that means this variable is involved in multicollinearity. First of all, we should not confuse this ri square with the overall model's r square. Overall model r square we want to be high, but this is different. Individual variable versus rest all variables. What we do is we don't even look at the r square. We create a new measure called VIF. VIF formula is 1 by 1 minus Ri square. VIF stands for variance inflation factor. If this R square is high, which means this Ri square for a variable is high, VIF will also be high. If Ri square is, let's say, 0.5, VIF will be 1 by 1 minus 0.5. That means 1 by 1 minus 1 by 2. 1 by 1 by 2. VIF will be 2. If Ri square is 0.75, VIF will be 1 by 1 minus 0.75 means 3 by 4, 1 by 1 by 4. VIF is 4. If Ri square increases, VIF increases. Just another measure derived from there. If Ri square is 0.8, this is when we start taking things seriously. This is when we say we are entering the serious case of multicollinearity, because 0.8, that is a benchmark, isn't it? R square 0.8. 1 by 1 minus 0.8 means 4 by 5. 1 by 1 by 5, 5. VIF for any variable, for a variable xi, VIF is calculated for every variable. If VIF is greater than or equal to 5, that variable is involved in multicollinearity. This is a clear case of multicollinearity. Multicollinearity is detected using a measure called VIF, variance inflation factor. How is it done? Once again, if you have this model y versus rest all variables, ignore y for some time. Take variable 1, use rest all variables, build a model, look at the r square, r1. Take second variable, use rest all variables, build a model r2, r3, r4, like that. For every variable, use it as a target, use rest all variables, build a model, take the r square value. If that particular r square is greater than 80%, then take VIF, which is like 1 by 1 minus r square, which is nothing but which is greater than 5. So for every variable we calculate it as r square, ri square for every variable increases, VIF also increases, but the benchmark, the level that we have beyond which we say there is a clear case of multicollinearity, which is VIF greater than 5. So if you want to detect multicollinearity, no matter how many variables are there, all that you need to do is just write a function that will take one variable at a time and use rest all variables and try to build the model and repeat the same for every variable, calculate 1 by 1 minus r square and give you the final output, the VIF value. VIF greater than or equal to 5, that is how you detect multicollinearity. Which means if you go back to our own problem, when you're trying to predict regional sales, okay, we have used the variable like average income, that was x1, x2 was average expenses, x3 was percentage of male, x4 was percentage of female. Okay, what we need to do is we have to calculate the VIF of x1, x2, x3, x4. Go ahead, calculate the VIF values. If VIF for any variable xi is greater than or equal to 5, then we can say there's a clear case of multicollinearity. That variable is related to others. We can say that. Go ahead, calculate the VIF values and let me know in the chat window if there is any variable that has more than 5 VIF. Is there any variable that has more than 5 VIF? Is there any variable that has more than 5 VIF? Tell me. Tell me what are the VIF values for average income? What is the VIF value? All of you try to please participate kindly. Try to use the chat window. Try to interact with me. So don't go far ahead. Okay. What we are doing, the code snippet that we are discussing right now is, so what are we doing right now? We are creating this VIF function. After that, there are 4 variables. For all those 4 variables, we are calculating VIF values. Only this bit you have to execute. Okay. So that will give you for these 4 variables, what are the VIF values. So tell me the result. Look at the VIF values. So go to here, go to runtime. Okay. Clear all output. Go to edit, clear all output. Okay. That will avoid the confusion. Clear all the output. Come to VIF function, create the VIF function. What is this function doing? It will take every variable, use rest all variables and try to build the model. That's it. Very simple function. Calculate the VIF values for the 4 variables. Here what we are doing is we are dropping region ID and regional sales. These are not required. Rest all 4 variables we are using. When we are using this drop function, if we are dropping columns, we have to put access equal to 1. While using drop function, if we are dropping rows, we have to put access equal to 0. Here we are dropping columns, access equal to 1, using rest all columns in the X data for calculation of the VIF. So what are the VIF values? Are you also seeing the same values, all of you? 863.43, 862.07, 11.31, and then 11.48, isn't it? Now there is a small twist in the plot here. because this is VIF greater than 5. This is also greater than or equal to 5. This is also greater than or equal to 5. This is also greater than or equal to 5. That means I have to drop all the 4 variables: average income, average expenses, percentage male, percentage female. I have to drop all 4 variables. That is totally meaningless, isn't it? We have built a model using 4 variables. We got around 85% R square. On the other hand, we are saying drop all 4 variables. If I drop all the 4 features, where the hell is my model? I don't even have a model if I am dropping the features. And how do I handle this situation? Why this has occurred? Here is the example. Let's say when you are building a model y versus x1, x2, x3. Let us suppose x1 and x2 are related to each other. x1 equal to 2x2. Let's say x1 is like income in dollars. x2 is like income in rupees. Both are related to each other. When you are calculating the VIF of x1, how do you do it? x1 versus x2, x3. So VIF of x1, will it be more than 5 or less than 5? In this example, VIF of x1 will be more than 5 or less than 5? So definitely it will be more than 5. When you are calculating the VIF of x2, you will be doing x2 versus x1, x3. So VIF of x2, will it be more than 5 or less than 5? VIF of x2 will be what? Will it be more than 5 or less than 5? Since x2 versus x1, x3, this will also be more than 5. Does that mean I drop x1 as well as x2, or I have to keep any one of them and drop the other one? If I have income in dollars and income in rupees, do I really need to drop both income in dollars or income in rupees, both of them, or I have to keep any one of them? If I drop both income in dollars and rupees, I will lose out the information on the income itself. Agreed or not? Drop dollars, then rupees will be independent. Drop rupees, then dollars will be independent. It is true that VIF values, they come like this in pairs. We should not drop all of them in one go. When you have the situation like this, drop the variable that has the maximum VIF, the most multicollinear, the most redundant one you have to drop first. Then you proceed to the next ones. So which variable has the maximum VIF value? First only drop that one variable. Maybe rest of the variables will be independent. So here in this situation, which variable are we going to drop from here? The variable that has the maximum VIF happens to be average income. That need to be dropped. I'll be left with 3 more variables. Is it fair to assume that these 3 will be definitely independent? Or do we need to recalculate VIF and verify it? Can we assume that these 3 will be definitely independent, or we have to recalculate? Usually we should not follow any assumptions, always recheck. Recalculate the VIF values only among these 3 variables. In this set, recalculate VIF. Recalculate VIF only among these 3 variables. VIF value average expenses is 1.07. Percentage male is 11.29. Percentage female is 11.41. There's not much of change here. There's not much of change here. But from 862, there is a monumental change. From 862, the VIF dropped to 1.07. Can somebody explain me the reason why it has been such a huge change? From 862, it has dropped to 1.07. What's the reason why it has dropped such a big number? What could be the reason? Is it simply random, or there is a meaning behind it? Can we interpret this? Looks like average expenses, average income was related, and you got rid of average income. Average expenses is carrying totally independent information that cannot be seen in percentage male, that cannot be seen in percentage female. That's the reason why it is now totally independent. Can we go ahead with these 3 variables, or still we need to go ahead and drop any other variable? Can we go ahead finalize the model with these 3 variables? Which variable are you going to drop next? Which variable? Are we going to drop both x3 and x4? We are going to drop the variable that has the maximum VIF. So we will drop this one. This one will be dropped. You will be left with two variables. Is it fair to assume that these two variables will be definitely independent, or do we need to recalculate VIF and verify it once again between two variables? Yeah, always on the safe side. If they are independent, it's okay. The VIF value will show, but we need to recalculate. So you're left with average expenses and percentage mail. Recalculate the VIF values. Recalculate the VIF values. VIF value for average expenses is 1.0, which is less than 5. This is also 1.0, which is less than 5. Which means for building this model, do we really need 4 variables or just 2 variables are sufficient? The information present in income is carried by expenses. The information present in female is carried by male. So we don't really need 4 variables. We just need only 2 variables. So this is like xi versus xj, whether two variables are independent or not. Are they really carrying independent information, or a copy of the information is shared across variables? That is given by this VIF multicollinearity check. We don't really need 4 variables here. We need only 2 variables. This way of looking at each and every variable, finding whether it is carrying independent information or not, is known as, this particular phase of model building is known as feature selection or elimination phase 2. Do you remember phase 1 of feature selection and elimination? What were we doing in phase 1? Phase 1 of feature selection and elimination, we are keeping all the variables that are impactful. That means x versus y. Whether x is impactful or not on y, only those variables we are keeping them. But what is this phase 2? X versus x, whether it is independent or not. This is a different step. Phase 1 was whether a variable is impactful or not. That is like x versus y. X has any relationship with y or not. Phase 2 is independence, whether x is carrying independent information or not. Okay. So these are the two phases that we need to follow when we are doing the feature selection and the elimination. Yes, we need to, once again, with these two variables, we have to go ahead and build the model. And I cannot give guarantee that these two variables within this, can I give guarantee that since they are independent, definitely they will be impactful? Can we give any such guarantee? Think about it. I have these two variables that are independent. Is there any guarantee that I can give that definitely this will also be impactful on Y? This will also be impactful on Y. Is there any such guarantee? No. How do I get to know whether this is impactful or this is impactful? What is the measure that will tell me? Is it VIF that will tell me whether it is impactful or not? What is the measure? Whether a variable is impactful or not? That is measured with a different measure. What is it? What is the, whether a variable, try to recollect carefully, given a variable, whether it is impactful or not. How do you get to know? I have given you a variable and I asked you, is it impactful or not? What is the measure? There is a dedicated measure for it. That is p value. You may have to look at the individual p value. So this is an independent step. This is an independent step. Both of them are not connected to each other. Let me do one thing. Let me recap all the steps while building this multiple regression model. First of all, I'll recap all the steps and then I'll take all the questions from you. You know what is step number 1? I'm talking about the model building steps. Before model building, what are the steps? Can you explain the function definition too? You mean to say the VIF function, this one? Kaushik, this one. So VIF, how do we calculate? We want to take one variable x let's say x1, x2, and so on, xk are there. We want to take one variable, use rest all variables for the prediction, build a model, look at r square, calculate 1 by 1 minus r square, and repeat the same thing for everything else. Look at this definition of the function. VIF cal is the function name. It takes the input data which is having all the x variables. Okay. So what are we doing? Or let me go to the code itself. It will be easy to understand from here. VIF cal, we input data it takes. Okay. For I in all the column names. So xvar names, I'm taking all the x variable names. I'm now going to iterate over all the column names. Okay. Y variable is from the x variables, I'll take the first variable. Right now I is 0. That means x0 variable. Usually Python indexing starts with 0. So you have taken the first variable as y. And by dropping that variable, rest all variables you have taken as x. So for the first model, variable 1 is y. Rest all variables are x. Is it clear? X and y. These two are clear until here. Yeah. Now what I'll do, I'll just build sm.ols y tilde x. What is y? X, my first variable. What is x? Rest three variables. Okay. Dot fit. Usually dot fit, then we look at the summary, get the r square, but directly dot r squared will give you the r square value. 1 by 1 minus r square. Print that 1 by 1 minus r square, which is VIF. Then this iteration will go to the next one. My second variable will be y. Rest all variables will be x. The same thing will be repeated. 1 by 1 minus r square will be calculated. Is it clear? Does it make sense? Any questions on this? Basically, the only thing that we are doing here is this particular loop. By taking all the x column names and running this loop is the only trick that we got it. Okay. All right. Before I start this, are there any quick questions? Do you have any questions? Okay. Usually the overall model building machine learning steps will be start with an objective. What is your objective? What is the goal, etc., etc. Defining the objective will be the first step. After that, you do the data collection, data exploration, data validation. After that, you do the data cleaning, preparing the data for analysis. Then comes the model building. Okay. Now I'm writing down the steps in model building. Those steps of setting up the objective, doing the data exploration, validation, data cleaning, those steps are common no matter which machine learning algorithm that you are using. Even you're not doing any machine learning, simple reporting also if you are doing, the steps of data exploration, validation, cleaning, data cleaning, all of them, setting up the objective, what is the goal of the project, those steps will remain always the same. Within model building, the first step is, if you are going to build a regression model, build the model, build the regression model by using all the features. The first model, you should always use all the features. The mistake that people do here is they pick and choose features in the beginning itself. Don't do that. Use all the features. At least all the features should be used. One feature should be given at least one chance. We cannot totally write off anything unless until like we are 100% confident. Tell me, right after building the model, what is the next step? I have built the model. The next step is right after model building. What is our next step? Model validation. So we had to perform model validation. Model validation measure in linear regression is R squared value. And what is a good industry benchmark? R squared value of our model should be greater than 80%. Let us suppose you have a good model. Immediately after looking at R square, what is the next measure that we are going to check? What is the next measure? Because sometimes R square may be high, but still the model is not good. So you're supposed to look at adjusted, an extra measure, adjusted R squared value. And what should be the value of adjusted R square? What should be the value of adjusted R square? A good value of adjusted R square, when we are looking at adjusted R square, for a good model, it has to be almost same as R squared value. If there are any issues, let's say if adjusted R square is very, very less, that means there are variables that are not really impactful. There are some variables in the model that should have been removed. How do you get to know whether a variable is impactful or not? How do you get to know whether a variable is impactful or not? We can look at the individual variables p values. If the p value of a variable is less than 0.05, I would say that variable is impactful. We can keep such variables. If the p value is greater than or equal to 0.05, such variable is not impactful. You can drop such variables. Are we done with all the model building? Is there any other step left? Is there any other step? By the end of this step, all the variables that are impactful are with me. Every variable, that means x versus y. I am keeping only those x variables that are having the impact on y. What I should check next? I should check for multicollinearity. What is multicollinearity? Within these variables, some of them are interdependent. Copy of the information is kept in them. How do you get to check the multicollinearity? How do you get to check the multicollinearity? I can check multicollinearity by looking at the VIF values. What are the benchmarks? How do you pick and choose variables based on VIF values? If VIF is less than 5, that means variable is independent or dependent. VIF is calculated for every variable. If for a variable, if VIF is less than 5, does it mean the variable is independent or does it mean the variable is dependent? It means the variable is independent. Independent variable should be kept or dropped. If a variable is independent, shall I keep them in the model? Yes, that is carrying independent information, keep them in the model. If the variable is having VIF greater than 5, the variable is dependent on others. That means copy of information is present in others. So you can drop such variables. But while dropping, we need to be careful, isn't it? While dropping, what is the point that we need to keep in our mind? Drop, that's all right, but drop the highest value first, drop one by one, isn't it? In a sequential order. Will you be able to remember this? Because a lot of people are doing a mistake here. I'll tell you, while I was giving this training in a company, the current existing process, they themselves are doing a mistake there. You know what they are doing? They are calculating the VIF of 30 variables or 30 or 35 variables they have. And let us suppose for 6 or 7 variables, VIF is greater than 5. And they wrote a code which will simply drop all the 6 variables. It will keep rest of the 24 variables and they are building the model. Can you tell me what is the issue there? They found the VIF and for 6 variables, VIF is greater than or equal to 5. And they dropped all those 6 and gone ahead with 24 variables. What is the issue there? Is it the right way of doing it? Yeah. The original data will be lost, isn't it? So you will be taking care of this one by one in a sequential manner. You have to do it. These two steps, step 4 and 5, they can be swapped in the sense, first you can find all the variables that are independent. Then you can come to variables that are impactful. Or first you can find all the variables that are impactful. Then you can come to independence. Whether you do this first or this first, there is no extra advantage or anything, both of them will give the same result. Doesn't matter which order you follow. But at the end of the day, the model that you are building will have all the variables that are independent as well as impactful. These are the steps you must follow while you are building the regression model. Even when you are working on any project, these are the steps that are expected from a client. So what I'll suggest is next time you have to practice these whatever steps that I have mentioned here, not on the same data set. Try to use a different data set. This is a different problem statement altogether. Web page, product, sales data. Try to follow all these steps. First, understand the problem statement carefully. Download the data. Look at the data carefully. Check whether there are any outliers or not. Okay. And try to predict the target. Identify what is the target variable. What are the features. Okay. And if you have any primary keys or customer ID or something, try to drop them. And then build the first model. Do all the checks. Build the first model. Look at the R square. Look at the adjusted R square. Look at the p value check. Look at the VIF check, etc., etc. Try to use this data for practice next time when you are doing the regression. Okay. These are the steps while building the model. Are there any questions on this? Has anyone worked on regression earlier? Is there anything that you have done? If you have any questions on that project also, we can discuss them here. Otherwise, we are done with regression. We can close this. We will move on to the next topic. So the question is, in the earlier example, we have checked the VIF values. What was it? So here we have checked the VIF values. As of now, based on the VIF values, these two variables are independent, which is that average expenses and percentage mail. Percentage mail and average expenses are independent. Now let us think, does it mean that they will be definitely impactful? We discussed this. Once again, let us discuss. Does it mean that definitely, since these two are independent, this also must be impactful, this also must be impactful? Is there any rule like that? Or a variable can be impactful or non-impactful as well? What do you think can be practical scenario? If few variables are independent, does it tell us anything about their impact? No. So whether this variable is impactful or not, if we want to check that, we need to look at the p-value. So look at the p-value of average expenses. Look at the p-value of percentage mail. Okay. If the p-value tells us that one of these variables or any of these variables is not impactful, we should drop that variable. So VIF will tell us whether two variables are independent or not. P-value will decide whether this variable is impactful or not. Okay. Is it clear? So these two variables are independent, but among these percentage mail is not impactful. So it may happen that some variables are independent, but still some of the variables, some of them are not impactful. Or first we would have seen the impact of the variables, then finally independence, both of them. Even if you follow this method of step 4 and 5, okay. First you have looked at the p-value, then come to VIF, that model. And first you look at the VIF, then come to p-value. Both the models R square values will be same. So it doesn't matter which step we are doing first. So the answer to that question would be drop the variable that is having higher p-value, go ahead with the rest of the variables. Okay. At the end of the day, the variables that you are going to display in the model, all the variables should be independent of everything else. All the variables should be impactful. Only that list of variables you are finally keeping them in the model. Rest all variables you are getting rid of. Okay. So whatever the client told us in this data set, it was actually inspired by some of the one of the original data set. Whatever the client told us, do you remember? The client gave us some information based on his business experience. He told that out of all these three variables, if you ask me, there is only one variable that is much most important. That is average expenses. Rest all variables are not at all important. That's what the client told us, right? Finally, that what the model also finally became. Okay. For this particular product, this is the scenario. Any other final questions on this? Let me tell you an important information here. All of you, please pay attention. The concept and the formula of R squared, the concept and the formula of adjusted R squared, the concept and the formula of calculating VIF, the concept and the formula of calculating p-value. Right now, we practiced all of them in Python. Do you think these concepts and formulas, do they change if tomorrow if I'm working on R, day after tomorrow if I'm working on SAS? Do they change from tool to tool, or no matter which tool you are working, these concepts and these formulas, let's say this is machine learning or regression model. This regression model concept, does it change from tool to tool? Does it really matter? The tool doesn't really matter, isn't it? Don't you think this regression or machine learning technique is tool agnostic, tool independent, isn't it? Tool independent. Whichever tool we are using, these concepts don't change. Which means Python is one of the tool that we are using. Tomorrow, if your client demands that you must work on R, will you be saying that, hey, I know only machine learning, I know regression model building only on Python. I don't know how it works in R. Is that our response, or are we going to say, I know machine learning model building, regression analysis, I know. Only the syntax of R, I don't know. I may have to quickly check that. But the rest of the things you should be able to handle. Do you agree with me? The whole step-by-step process. Only thing is syntax in R changes. Once somebody gives you that syntax, you should be able to do the same verification of R square, above 80% adjusted R square nearby. This concept doesn't change. Do you agree with that point, all of you? The reason why I'm highlighting this here is tomorrow you may have to work on a different tool. You should not say that I know only Python, I don't know machine learning on any other tool. No. Be prepared for any other tool. IBM has its own tool called SPSS. IBM is also creating some more new products, almost automating this whole step, like step-by-step process we wrote, right? 5 or 6 steps. IBM Auto ML or something, there is one cloud product that they are creating. It will automate all this process, which means you don't need to do anything. You just need to interpret the output. You don't need to write the Python code for it. The package or the tool or the cloud, some automatically it is going to do on its own. No matter whichever IBM cloud, whatever you are going to use, you should not be bothered about the tool. At the end of the day, what really matters is the conceptual understanding. I'm assuming that all of you have got that conceptual understanding. You should not be really worried about the tool. Yes, we have practiced everything in Python, but you must be prepared for any other tool. Are you confident of that, all of you? Tool doesn't really matter. So go ahead. If a project is on a different tool, take it confidently. Only thing is, you may have to learn the syntax of that tool. Try to only think about that. But machine learning concept as it is, it doesn't change from tool to tool. This concept is tool agnostic, tool independent. It doesn't matter which tool we are using. Even within Python, there's a different package that comes up. Until now, we have used stats, models package, isn't it? If there's a different package, let's say the package name is sklearn, which can also do linear regression. Within a tool also, within Python, from package to package, slight syntax difference will be there. What I want to highlight here is the tool or the package doesn't really matter. The process of building the machine learning model remains the same. From package to package, tool to tool, only syntax will be different. Okay. So we learned the concept of regression and we are ready to work on any tool. Let us suppose if we are doing the same regression exercise in sklearn, let us see what is the difference. Let us take a very simple example. I want to predict based on the age, based on X value. I want to predict the target value Y, which is the person has bought the product or not. X variable is age, Y variable is whether the person has bought the product or not. X and Y, if I am building a regression line, how that would be. Earlier we used stats models package, stats models, but now we are using a different package. Imagine this is a different tool altogether. In this exercise, imagine this is R, this is SPSS or a different tool, which means you will be writing different syntax. So here is the syntax in the new package. From sklearn, import the package. LR equal to linear regression. This is my model name. Linear regression is the model that I'm going to build. LR.fit x comma y. In sklearn, we have to give x comma y, x1 plus x2 plus x3 plus and so on plus xk, comma target variable y. X variable is age, y variable is bought. Whereas in this stats models, until now we have used a different syntax. We used to write y tilde x1 plus x2 plus x3 plus and so on plus xk. This is the syntax demanded by stats models, but sklearn has different syntax rules. We have to follow whatever is the rule given by that package. So we have to first mention x, then mention y. Then the model will be built. Then here we used to write model.summary. Until now we used to write summary, but there is no such summary function here. You have to ask one by one. Model.coefficient, then you will get coefficient. Model.intercept, then you will get intercept. Model.some matrix.r square, then you will get r square. Like that, one by one you have to get. Everything will be calculated, stored in a model object called LR, and we have to get all the properties. In fact, you can also say your model name is LR here, model.predict, and you can give the x variable value, then you will get the predicted value of y. You can give any number of values here. So what I'm trying to say is, whatever is the package and the tool that you are using doesn't matter. The conceptual understanding is only that is required. When I started my career, I used to work on SAS. I worked on SAS for 6 years. There was no other tool back then, from 2008, 9, 10, 11, 12, during that time. Afterwards, R became famous. I have slowly started working on R. SAS almost did not exist later on. It has vanished very quickly. Then nowadays, in fact, I gave a lot of trainings on R as well. But in last 4-5 years, or especially last 4 years, a lot of training requests are on Python. Now I'm working on Python. Let me tell you whether I was working on R or SAS or Python. Exactly same examples I was using. My material was exactly same. The only thing that changed from tool to tool was the syntax only. Only that syntax slides will be updated. This slide in a SAS slide, code slide will be there. That will be different slide in SAS. That will be different slide in R. By mistake, sometimes I used to pull R material. Then suddenly we used to realize we are looking at R PPT some time back. Nowadays, there are no requests on R. Completely almost 90% of the training requests are on Python only. Go ahead. Let us open this code file, quickly check this logistic regression code. Let's go to logistic regression. Logistic regression. Try to open this code file. Leave the page. We haven't started what is logistration. You can consider this as a recap of the linear regression recap. That is the session that is the snippet that you have to execute. Go ahead, open this code file, execute this code one by one, run this cell, run anyway, run this cell, okay, and then get me the predicted values. When age is 4, what is the predicted value? When age is 105, using this model, get the predicted values. Yes, I got the predictions. When age is 4, the predicted value is minus 0.0866. When age is 105, the predicted value is 2.02. Once you are done with this, once you have these predictions, send me a message. Once everyone has these predictions, then we'll go ahead with the discussion. All right then. Look at these predictions carefully. If you look at the data, our data was like this. We have the age variable. It's a very simple model. And based on the age, we are predicting whether the person will buy the product or not. The product can be anything. Something like home loan product or something like auto loan, something like an insurance. Based on this variable X, we are predicting whether this person will buy that product or not. The target variable takes two values only, zeros and ones only. 0 means the person is not buying. 1 means the person is buying the product. Very simple. A person with this age is not buying the product. A person with this age is buying the product. Now when age is 4, the predicted value is minus 0.08. When age is 4, the predicted value is minus 0.08. We know the meaning of 0. We know the meaning of 1. We do not know the meaning of minus. We cannot assume that minus means not buying. No. So there is something wrong here. Because we are getting a prediction that is not part of the data. We never knew the definition of a negative value. So there is something wrong here. Whereas if you go to age 105, the predicted value is 2.02. We know class 0 means not buying. Class 1 means buying. We don't know what is class 2. This is also, there's something wrong. We cannot simply assume that 2 means buying 2 items. We don't know the meaning of 2. We have never seen a 2 previously. So nothing about 2 can be assumed. There's something wrong here. There's something wrong here. Something is totally happening grossly wrong in the background. Here is the data. This is how the data looks like. On the x-axis, you have the age variable. On the y-axis, you have the person buying or not buying, 0 or 1. Okay. Now there is nothing like 0.82, 0.65, 0.42, 0.28, 0.15. There is nothing like that. Either 0, which means not buying the product. Clear? Class 1. This is class 2. Buying the product. Zeros and ones are only available in one. Now for this data, we built a regression. Regression means linear regression. Why it is called linear regression? Because the model equation is y equal to beta naught plus beta 1x. This is the equation of a straight line. Straight line means linear line. We have built a linear regression line, which means we tried building a straight line. Is it possible for a straight line to go through almost all the points in our data? Is it possible? No matter what optimization that we do, no matter what technique we use, is it possible for a straight line to go through all the points in our data? Is it possible? It's absolutely impossible for a straight line to go through, if not all the points, going through most of the points for this particular type of data. It is impossible. That is why linear regression fails for this type of data. A linear regression model is not a silver bullet that will work on every type of problem in this world. Definitely, it will fail when it comes to classification problems. What is a classification problem? When the output is either 0 or 1. This is known as binary classification. There are some kind of multi-class classifications also, which we are going to discuss. There also it will fail. In place of classification, where the output is either 0 or 1, in these places, linear regression fails. Is it a very rare example, or are there any other examples like this in the real world? Here are some of the real world examples. In sales, based on the customer profile details like customer age, customer gender, customer income, the place or the region where he is living in, based on the expenses, based on all the customer profile details, I'm going to predict whether this customer will buy the product or not buy the product. This will help me in targeting the customers. Again, based on the customer profile details in marketing, let us suppose I'm a insurance marketing team. There is a hell lot of people who are sitting there and who are going to make the calls to sell my insurance product. Now, I want to predict whether the customer is going to respond or not respond. Based on the age, based on the gender, based on the income, based on the region, based on the expenses, based on the credit score, based on the number of loans, based on all the data that I have with me, I want to predict whether the customer will respond. Then only I'll make a call. Otherwise, unnecessarily, there is no point in calling random people who are not going to respond to my insurance call. In credit cards and loans, before giving a loan, I want to predict whether the customer will be a defaulter. Defaulter means bad customer, or non-defaulter, paying back on time, good customer. And what are the variables that I will use? I'll use features like customer age, customer number of dependents, customer monthly utilization. Do you remember monthly utilization? Customer income, customer number of late payments in last 6 months, last 1 year, etc. I'll be using all these variables, full financial history, for predicting whether the customer is going to be a bad customer or good customer. Based on the customer usage, based on the number of complaints made by the customer, based on the number of service plan changes, based on the customer usage data, I'm going to predict the customer is going to attrite, churn out, or stay back. Based on the clickstream data, based on what websites you have visited in last 6 months, based on how much time you have spent on social media websites, based on what links you have clicked in last 6 months, based on the complete clickstream data, I can get a hell lot of data. Only storage issue is there with me. Otherwise, I can get complete profile of the customers. No matter what security software you have installed, clickstream data is very easy to access. Based on the clickstream data, I want to predict whether you are going to click on the advertisement or not. If you are not going to click on the Switzerland holiday advertisement, why should I display it to you? If there's a high chance for you to click on a mobile phone advertisement, smartphone advertisement, then I would rather try to show you a smartphone rather than Switzerland holiday. Whenever you swipe a card, I can get hell lot of information. A single swipe of the card, we can get what is the amount that you have swiped for. Who is the vendor? What is the vendor code? Is it a restaurant? Is it a bar? Or is it a grocery store? I can get that information. Where is that restaurant located? What time you are swiping it? What is the average amount that you have swiped? What are the number of transactions that you have made? Within one swipe, we can get all those details. Based on all those details, very quickly I have to predict, based on all these features, is it a fraud transaction or non-fraud transaction? In fact, in real world, if you ask me honestly, in the industry, 90% of the problems, or more than 90% of the problem statements are classification problem statements. Classification. Usually, the one that we discussed until now, they are called linear regression. In short, they are known as regression problems, where the output is continuous. The number of passengers is a regression problem. Okay. The loss percentage is a regression problem. Website visitors, it's a continuous range of values. That is a regression problem. If the output is 0 or 1, buying or not buying, respond, not respond, default, non-default, attrition, retention, click versus no click, all these are classification problems. For all these classification problems, a linear, a straight line, linear fails. We have seen it. Fails in the sense Python will not throw any error. It will build the model, but the predictions will be wild, very wayward. We'll be getting the predictions that are not even there in the data. Like the way we got minus value, 2 value and all that. Those kind of predictions we'll get. Linear regression fails. Then we have to search for non-linear, not straight line. Linear fails, go for non-linear functions. There are several non-linear functions, but some of the functions are pretty much suitable for our kind of data. So our data is like this. You have zeros here, you have ones here. For this type of data, out of the examples that I have given as non-linear functions, which one do you think suits best for our type of problem? Which non-linear function? If you look at double exponential, it covers all the zeros. However, the ones are not covered, so double exponential is not good. So which one do you think is going to suit perfectly for our data, or nearly perfectly, if not 100% perfect? Which nonlinear function? The nonlinear function that works almost perfectly for our data is logistic function, because our data is either here or here. Logistic regression also has longer tails like this. Okay. And it is always between 0 and 1. Logistic regression or logistic values, logistic function values are always between 0 and 1. So our output is also either 0 or 1. That is why instead of building a linear regression line, a linear regression line is a straight line. We are going to build the equation is y equal to beta naught plus beta 1x. Instead of building a linear regression line, we have to build a logistic regression line. This is known as logistic regression line. A non-linear regression. Non-linear means not straight line. Even logistic regression is not 100% accurate. Check this out. It will make a error prediction here. This will be a misclassification error here. But in reality, is it possible to get 100% accurate, or it's okay if we are getting some error? In real world, what is the accuracy that we look for? Are we always after 100% accuracy? Overall, the model should do a good job. It should classify most of the points accurately. Even if it is making few mistakes here and there, that is still acceptable, because in real world we cannot expect picture perfect theory. So we can, even overall, if it is doing a good job of classification, it should be fine. Like the way there is an equation for a straight line, this ends up like a straight line. There is an equation here as well. So the logistic regression equation is y equal to e power beta naught plus beta 1x divided by 1 plus e power beta naught plus beta 1x. This is the logistic regression equation. We find beta naught beta 1 in linear regression, but that is from a straight line. We find beta naught beta 1 in logistic regression, but that is in this equation. Beta naught is intercept, beta 1 is coefficient. Same way. But the thing is, this equation is different, this equation is different. This will end up like a straight line. This will end up like a S curve. So here is the logistic regression line equation. So if we go back to our problem statement earlier, whether a customer will buy the product or not based on age, where buy takes zeros and ones, zeros and one. We have to build a logistic regression line here. Logistic regression line. What will be the difference in the code? There will be only one change in the code. Earlier we wrote model equal to linear regression. A straight line was assumed. But now if you say logistic regression, automatically this S curve, this will be assumed. Logistic dot fit x comma y. The model will be built. Model dot coefficient, model dot intercept can be seen, and model dot predict can also give you predictions. So instead of building a linear regression here, we are building a logistic regression. Go ahead, execute this code snippet, but this time try to use a logistic regression. Tell me what are the predicted values for age is 4 when age is 105. When age is 4, the predicted value happens to be 0. When age is 105, the predicted value happens to be 1. Whatever is the meaning of 0, maybe 0 means not buying. Then we'll say predicted value is not buying. When age is 105, the predicted value is buying. Like that. Before I move on to the next slide, are there any questions or clarifications that are required? Please let me know. All right. Will this model give always 0 and 1? In the sense, is always classification binary classification like 0 and 1? If that is the question, the answer is sometimes there can be multi-class classification as well. The output could be 0, 1, 2, 3, 4, limited, but the output could be any one of these classes. Okay. For them, there are other classification algorithms as well. For a binary classification, this kind of S curve works perfectly, which always gives 0 and 1. But multi-class classification problems in the real world are possible. Okay. In fact, we are going to discuss tomorrow one type of multi-class classification where you have a possibility of 9 classes in the output. So once you give an input, the output can be this class or this class or this class. So in general, multi-class classification problems also do exist. First, we will now discuss the binary classification. We will move to multi-class classification in the one of the upcoming session. You know what? You have to look at the problem statement, all of you. You have to look at the problem statement. You have to look at the target variable. Look at the problem statement. Look at the target variable. And you must decide beforehand, just by looking at these two pieces of information, you must decide whether it is a linear regression problem or whether it is a classification problem where I'm going to solve it using Logistic. You must develop that intuition, because for a classification problem, if you apply linear regression, that will be wrong. The whole result will be wrong. But Python will not throw any error for you. Python is not your friend. Python will give you the result, but the results will be wrong. Similarly, for a regression problem, if you apply classification, the whole analysis will be wrong. You must look at the problem statement. You must look at the target variable and decide whether it's a linear regression or classification problem. I'm going to give you some problem statements now. I would like you to respond in the chat window what type of model that you are going to apply for these type of problems. Put number 1 in the chat window. Tell me what type of model is that? What type of problem is that? Is it a regression problem or a classification problem? This one is a regression problem. Usually linear regression is termed as regression only, a shortcut name kind of thing. Put number 2 and tell me what type of problem is that. This is a classification problem. I'm going to solve it using logistic regression. Number 3. Number 3 is a regression problem. Number 4. Number 4. This one is a classification problem. Number 5. Five is a regression problem. Number 6. Number 7. Number 8. Number 9. Ninth one is a fraud identification model. This is a classification. 10th one, since this is also fraud, this is also fraud. Since this is classification, so I can assume that this will also be classification only, right? Since this is also fraud, this is also fraud. The same model can be applied? No. This is fraud, but identifying fraud versus no fraud. Whereas this one is amount of fraud. The fraud amount can be $1, $2, $10, $15, $30, $100, $200, $2,000, $5,000. The amount of fraud is a continuous value. So this one, 10th one, is a regression problem. Like this, in future, no matter what problem you are facing, will you be able to decide whether it's a regression problem or a classification problem, will you be able to take that call on your own? Because that is critical. If we do mistake here, we will be doing everything else follows will be wrong. I'm sure you'll be able to take this easily, isn't it? It's not a very difficult problem. Once we have a good look at it, we'll be able to detect whether it's a classification or regression problem. Like the way we have simple regression, which is like y equal to beta naught plus beta 1x. If we are using multiple features, then we have multiple regression model. What is it? Beta naught plus beta 1x1 plus beta 2x2 and so on plus beta kxk. We also have simple logistic regression line y equal to e power beta naught plus beta 1x divided by 1 plus e power beta naught plus beta 1x versus multiple logistic line, which means it's not always a single variable that will impact the target variable. Person buying or not buying will not just depend on one variable. Multiple variables may actually impact. This is the multiple logistic regression line equation. E power this whole thing divided by 1 plus e power beta naught plus beta 1 x1 beta 2 x2 plus and so on beta k xk. This is the multiple logistic regression line. All these multiple features are used for the prediction of the target variable y. Again, we have those list of all the steps that we used to follow in linear regression. Again, those steps, some of those steps analogous to those. Again, here also there is a long story in logistic that is going to follow here as well. As usual, what we will do is we will take a case study, one by one concept. We'll be discussing that and we'll be verifying that in that case study. Okay. This is the multiple logistic regression line, but have you understood the clear difference between linear regression and logistic regression? All of you, is it clear by now? Linear and logistic, there's no confusion on that. Yeah. When to go for linear regression, when to go for logistic regression. What we will do right now is we will take a particular case study and then we will discuss all the concepts one by one. Okay. What I want you to do is there is a data set called fiber bits data. I'll explain you the business case. I'll explain you what are the type of teams that use these type of models, etc. First, import this fiber bits data. Look at the info. You should get this as the output. Once you have this output, let me know. Import this fiber bits data. Yes, imported. Perfect. The model that we are going to build here is going to be really useful, especially if some of you are going to definitely work on data science projects. You will get a chance to work on exactly similar type of model that we are going to use right now. These type of models are known as churn prediction models, customer churn prediction. Have you ever heard of the churn prediction or attrition prediction? It is known as attrition or churn prediction. Let us suppose if in a region or for a particular product, let's say there are 10,000 customers. I am building a model that will predict that these 8,500 customers are going to stay back. These 1,500 customers are going to churn out or attrite. That means they're going to leave, stop using my product or the service. They're going to leave us. Have you ever heard of the churn prediction model? Can you think from the business point of view, what is the use of it? You have 10,000 customers, all of them are right now active on your books. I told you in next 6 months, these 1,500 guys are going to leave. What's the use of such model? Where can you use it? What can you do after knowing this info? I told you these 1500 guys are going to leave, these guys are going to stay back. What can you do? Once we predict who are the customers that are going to churn out, to retain these customers, we run some retention strategies. We are going to run some retention strategies. One of the most widely used retention strategy is waive off. We are waiving off your late payment charges. We are waiving off your 1 month charges. Have you ever got a retention offer applied actually on you? Do you have any first-hand experience of a particular company or an app or a service? They told you, they sent you a message saying that come back, use this coupon, we are waiving off this, or try to use this coupon, come back, or something like that. That means, let's say, if you suddenly stopped using Swiggy, then maybe every month or every week they tend to run these models. If they predict that you are going to churn out, they tend to send you one offer. Next time, try to observe some of the SMSs are exactly based on the lines of retention from big basket, especially these apps nowadays that we are seeing, all these startup apps, they have a lot of fund, so they will be running a lot of campaigns to retain the customers. Behind the scenes, it's not random. Behind the scenes, they are going to run this churn prediction model. The churn prediction model predicted that you are the guy who's going to churn out. That is why they are sending you, and the message that you got is not the same message that someone else is going to get. You are the guy who's going to attrite or churn out. That's why you are getting the retention offer. Generally, business believes that retaining an old customer is easier. Getting a new customer is twice difficult. That's why they always try to run after the people who are going to churn out. For running the retention offers, we require this churn prediction model. Come to this one. These 8,500 customers, they're going to stay back. Do you know what do we do with them? We run some strategies called cross-selling and upselling strategies are run. Because you are a loyal customer, you're going to stay back. If you have product A, if I'm trying to sell you B or C or D, this is called cross-selling. Let's say if you have used our internet, try to take our TV, try to take our SIM phone, mobile or something. Like Reliance Jio if you have mobile phone, Jio mobile if you have. Try to take Reliance TV, Jio TV, try to take Jio internet, fiber net. That is called cross-selling. Try to maximize. At the end of the day, we want to squeeze as much revenue from the customer as possible. That's the only criteria that we have. Upselling means if you have product A, try to upgrade to 2A or 3A or 4A like that. Upselling, selling the same product. I don't have any other product, unfortunately. My name is Act. I just have one product. Then what I'll do, I'll try to push you to somewhere upper baskets. Right now you're using 30 Mbps speed. Try to push yourself to 50 Mbps. Try to push yourself to 80 Mbps. These kind of cross-selling, upselling strategies. If you observe next time carefully, you will also try to see, like if you have a savings bank account in a bank, they'll try to sell you an insurance. They'll try to sell you a loan. They'll try to sell you a fixed deposit. These are all not random calls, by the way. Behind every action that a marketing team is doing, definitely these type of churn prediction, attrition analysis, retention analysis, all these things are actually done in the background. Okay, some team must be doing it. And nowadays, any customer facing company, it's a must for them to predict who's the customer who's going to stay back, who's going to, retain. We're going to use a data set, very rich data from a internet service provider company. So what we'll do is we'll take a break. After the break, I'll explain you who is this, what is this data all about, what are the columns. We'll understand the problem statement and we will see how can we solve it using our logistic regression and all that. And then we'll follow the rest of the steps. Before going to a break, if you have any quick questions, please let me know. Well, if there are no questions, let us take a quick break. Let's meet at 11:30 and then continue this discussion. So the Google Classroom classwork link is not required. So how do you access the Google Classroom? This is the way that you have to go to. Open a blank tab. You can do it along with me. Open a blank tab and type Google Classroom. Okay. Since you have enrolled once, you don't need to re-enroll. You don't need any link anymore. You can do the same thing even after 6 months, after 1 year, after 5 years or 10 years. Go to your Google Classroom. Since you have already enrolled, you will be able to access anytime later on. Go to your Google Classroom. Then it may ask you to log in, and if you have already logged in, go to Google classroom.google.com. Click on this classroom.google.com. I can easily share the link, but in future, some of you might want to access this. That's why I'm showing this all again. Then you will see the cards. One of the card is data science, machine learning. What is the card right now? The IBM, this one. Have you got it? And at the top, classwork. Any questions on this? Have you got here? No? Works? Yeah. Perfect. The same process. So you don't really need the link. Any other questions, anyone, before we break? All right then. Let's meet at 11:30 and continue this discussion. Welcome back, everyone. Once you are back at your desk, send me a message. Let's give a minute for others to join in. The next problem that we are going to work on has been shared by one internet service provider company. They want to build a churn prediction model. They have gathered a large data set, roughly in last 2 years. What they have gathered is they have gathered the data of around 1 lakh customers. For every customer, at the end of the 2 years, whether the customer is active or whether the customer is inactive, that means whether he is still active or whether he left, churned out, is what they have tracked. Active customers take value 1. Inactive means 0. That means these customers have left, churned out. These are the guys who churned out, attrited. These are the customers who are still active. There are some customers who are active, some customers who are inactive, which means attrited. Now there are some other internal variables that were also tracked. Their average estimated income of the customer months on network, how many months the customer has been on the network or with our services, number of complaints. Do you think attrition has anything to do with the number of complaints? Do you think the number of complaints, do they matter? Yeah, definitely yes, isn't it? If a customer is giving a lot of complaints, then attrition could be higher. So the target variable here is active cust. Whether the customer is active or inactive, that's the target variable. 1 lakh records are there. We have feature 1 income, feature 2 months on network, feature 3 number of complaints, feature 4 number of service plan changes. Customer is frequently changing the plans. Is he not satisfied with the existing plan? Customer, whether he relocated or not. If a customer is relocated, we may not be present at every location. We may not provide him services. Then also customer goes inactive. Monthly bill, technical issues per month, speed test results. We are promising a certain speed. If we are not achieving it, then we may get into that customer attrition. This is the target variable, active or inactive. These are the features. It is a very obvious question. Is this a regression problem or is it a classification problem? Is it a regression or a classification? Looking at the output, I can check that the active cust takes 2 values, 0s and 1s. It's a classification problem. We are going to use the algorithm of logistic regression. Here is the syntax. Import the package, define the model. Logistic 1 is my model name, is equal to logistic regression. Model.fit x1 plus x2 plus x3 plus x4, x5 and so on plus xk. First mention all the features followed by the target variable y. This is the target variable. At the end of this, the model will be built. We will write model.coefficients. We'll get the coefficient values. We will write model.intercept. We'll get the intercept value. But that is only model building part. As we know, as a good data scientist, right after model building, what is our first role? This is only half of the job. Model building must be always followed without any hesitation. Model building must be always followed by model validation. When we were using linear regression, we have the y actual values, we have the y predicted values, we have the error. All the errors lead to sum of squares of error. All the predicted values lead to sum of squares of regression. All the actual values lead to sum of squares of total. Sum of squares of regression divided by sum of squares of total, that is R square. That's the model validation measure. Here, a different measure is used because this works perfectly for regression. For logistic regression, our problem statement is different, target variable is different. So we are going to use a slightly different method to check how good is my logistic regression model, goodness of fit or model validation for logistic regression. Here is the process. Do you have the data? Yes, I have x1, x2, x3, xk variables are there with me. Do you have the target variable? Yes. Y is my target variable called y actual. What values does it take? It takes zeros and ones. There are some places where it takes 0. There are some places where it takes 1s. Do you have the model built? Yes. Can you use model.predict function? Can you supply the first row? Can you get the y predicted value? Oh yes, I can get y predicted value. Have you ever done it earlier? Yes. I have supplied age 4, I got the predicted value. I supplied age 105, I got the predicted value. Logistic regression predictions. Similarly, we will supply the data of x, we will get the predicted values. Imagine these are the predictions are also zeros and ones only. These are the actuals, these are the predictions made by the model. These are the actual classes, zeros and ones. These are the predicted classes. Based on these actual and predicted classes, now we are going to create a matrix here. In this matrix, the rows will be y actual classes, which are nothing but zeros and ones. The columns will be y predicted classes, which are nothing but zeros and ones. Okay. Imagine this itself is your data, just for the discussion sake. This is the data. How many times the actual class was a 0 and the model also predicted it as 0? Count the number of occasions 0 has been rightly predicted as 0. Tell me, how many occasions did that happen? Once, twice, twice. There are 4 such occasions where model has predicted 0 as 0. Is it a good job by the model? Yes. Actual value is 0. Model is also predicting it as 0. Pretty good. Very good. How many occasions? The original class was 1. Model also predicted it as 1. 1 has been predicted as 1. How many such occasions it happened? 1 is the original value. It has been predicted as 1. Count them and tell me. 1 actual predicted as 1. 1 has been predicted as 1 once, twice, twice, 4 times. That is also 4 times. Is there any doubt in that? 1 has been predicted as 1, 4 occasions. Good job by the model. Good job by the model. What are the errors made by the model? Let us see. Original class is 0, but model has done a mistake. 0 has been predicted as 1. How many occasions 0 has been predicted as 1? Here. In how many occasions 0 is the original class, but the model has done a mistake of predicting it as 1. Here is the mistake. 0 is the original class, predicted as 1. There is one such occasion. Bad job by the model. 1 is the original class, but has been predicted as 0. Second type of error, another error. 1 is the original class. Actual value is 1, but model has predicted it as 0. Not a good job by the model. How many such occasions? One such occasion. Overall, how many rows are there in the data? How many times you have used this model for prediction? Overall number of places where you have used this model. Number of rows overall. 10 places where you have used this model. Out of them, How many occasions your model has done a good job? How many are accurate predictions out of 10? 8. What is the accuracy of the model? 80% is the accuracy. This matrix that you see here, where you have y actual values, y predicted values, this is known as confusion matrix. What is it? Confusion matrix. For classification problems, for all the classification problems, the model validation must be done by using the confusion matrix. First create the confusion matrix. After that, add this number plus this number to get the output, which is like accuracy. Accuracy must be derived based on the confusion matrix. First, this matrix need to be created. How do you create this? You have y actual values from the data. You get y predicted values from the model prediction. Then you can create the confusion matrix, get the accuracy. General benchmark, as we know, must be accuracy must be greater than or equal to 80% to make it as a good model. So take the y actual, take the y predicted, create this matrix. Sometimes 0 is known as positive. 1 is known as negative class. 0 is positive class. 1 is negative class. Predicting positive as positive. Predicting positive as positive. Truly as positive. What is this called? True positives. Predicting positive but falsely predicting them as negative. Original class is positive, but the model is falsely predicting them as negatives. What is this known as? This cell over here is known as false negatives. Original is positive, but model is predicting them as negative. Actual value is negative, model is falsely predicting it as positive. What is this called? Actual value is negative, model is predicting them as positive. False positives. What about this one? Negative rightly predicted as negative. Negative rightly predicted as negative, true negative. Sometimes in some of the tools at some places, people might be calling this as true positive, false negative, false positive, false negative, like that. You must know what is the class of positive. Usually 0 is by default positive class. So based on that, you may see these kind of notes also made: true positives, false negatives, false positives, true negatives, like that. The model validation for the classification models must be done using the confusion matrix and the accuracy. Go ahead, you build this model, create the confusion matrix. So here is the code for confusion matrix creation. Get the predicted values by using model.predict. These are the y actual values. These are the predicted values. Supply them to confusion matrix. Find the overall number of records, which will be 1 lakh. That will be the total. CM00, CM11. That means those diagonal elements, true positive, true negatives, divided by overall number of records will give you the accuracy. Go ahead, build this model. Tell me the accuracy. If everything works fine, you will get the accuracy of the model to be around 85%, 85.6%. Now, multicollinearity. In one phrase, in one sentence, what is multicollinearity? We discussed multicollinearity in linear regression earlier. When we are predicting target variable y, in linear regression, the target variable is a range of values. It is nothing but the interdependency between the features. These features, if there is a duplication of information, one or two or three or more features, they are giving us the same information, then we can remove that copy of the information, keep only independent variables. That's what the definition of multicollinearity is in linear regression. But when you come to logistic regression, you have y versus x1, x2, x3 and so on, xk variables. The only difference from linear regression to logistic regression, earlier in linear regression, the output is a range of values. In logistic regression, the output is either 0 or 1. If you look at this system carefully, from linear regression to logistic regression, where is the biggest difference? Is it in the target variable or is it in the system of features where we have observed a huge change? From linear regression to logistic regression, almost the features are almost remain the same, similar. But the target variable earlier was a continuous variable. Now it will be a classification variable. But when it comes to multicollinearity, I don't care about the target. We forget about the target for some time, isn't it? Multicollinearity is an issue that is connected to only features. So the issue that we have there connected to features, the same issue is here as well. Even in logistic regression where the output is 0 and 1, if there is a duplicate of information, income in dollars, income in rupees, multicollinearity will be an issue. That means the beta coefficients that you will get will be showing you some wrong values if you have multicollinearity existing. That means the individual interpretability, whether x2 is positively related, whether x2 is negatively related to the target variable, those will also go wrong if you have multicollinearity. Multicollinearity, the problem almost remains the same here as well as here, because target variable doesn't matter. Multicollinearity, detection and all that, we don't even care about target variable. So the same issue of multicollinearity is observed even in logistic regression, which means if two variables are giving same info, we need to only keep one of those independent variables. The lucky point here is whatever is the process that we followed there to detect multicollinearity, to eliminate multicollinearity, that process doesn't change, because in that process we ignored y. Here also we ignore y. When you ignore y, whatever you process the followed here can be exactly same as the process here. So for detection of multicollinearity, what is the measure that we use? How do we detect multicollinearity? We have to calculate VIF values for detection of the multicollinearity. If the VIF value is less than 5, it is an indication. VIF is calculated for every variable. VIF of variable x1, x2 and so on. For every variable, VIF is calculated. If VIF is less than 5, then the variable is independent, the feature is independent. You must keep that feature. If VIF is greater than or equal to 5, that feature is dependent. You can drop such features. So the same process we have to follow, which means the model that you have just built, it gave you 80% accuracy. However, looks like how many features you have used, by the way? In this model, you have used x1, x2 and so on, x8. 8 features we have used. x1, x2, x3 and so on, x8. 8 features you have used. Out of these 8 features, whether which features are independent, which features are dependent, we don't know. I would like you to calculate the VIF values for each of these features and then let me know, is there any feature that is having more than 5 VIF. Eight features are there. Is there any feature that is having more than 5 VIF? So in the output, let me also do it. In the output, this is a linear regression. So if I go here until multicollinearity, let me execute until here. Runtime, run before. So I got the message that out of 8 features, there are 2 features. One of them is number of plan changes. Number of plan changes. That is one feature that has more than 5 VIF. Precisely the VIF value is, how much is a VIF value? VIF value is 11.98. 11.98. And the second variable, technical issues per month. Technical issues per month. That has a VIF value of 11.4. 11.44. So we are going to drop these 2 variables and we'll be left with 6 features. We are going to carry forward these 6 features. Is that what we are going to do? Is that the right option? What we should do? Shall we remove both the variables? No. The important information here is when you have 2 variables with more than 5 VIF or many more variables with more than 5 VIF, only go to that variable that has the maximum VIF. First drop only that variable. That means drop this. You will be left with 7 features. So recalculate the VIF within those 7 features. Go ahead, recalculate VIF among 7 features. The one with max VIF, number of plan changes, need to be dropped. You will be left with 7 features. Among these 7 features, are there any variables that are having VIF more than 5? Within these 7 features, there are no variables. All the variables have VIF less than 5. Even if we go to the code file, if we execute this, we will see that all the variables have VIF less than 5. Why suddenly number of these technical changes per month? Right now, it is 1.49. Earlier, it was 11 point something because we have removed some dependencies. 7 features are there. So all these 7 features are independent. Independent means they don't depend on each other. All these 7 features are independent. Does that mean they are all impactful? Can I say all of them are impactful? Independent means what? Xi is independent of Xj. What is impact? Xi is impactful on Y or not. Does this mean this one? Or do we need to check this separately? What do you think? To check this, the individual impact of the variables, we need to look at the p-value. In linear regression, behind the scenes, there was a different formula. Finally, it boils down to p-value. For logistic regression, a different formula will be used. That will also boil down to a different version of the p-value. Okay, finally, everything will be ending up in a p-value. The interpretation also remains the same. Background calculations of arriving at the p-value are separate for linear regression and logistic regression. Neither in linear regression nor in logistician we will not go to those formulas. Finally, we'll take this p-value and interpret it. P-value is calculated for every variable. If the p-value is, what are the benchmark limits? Tell me. For the p-value, what are the limits, benchmarks? If the p-value is less than 0.05, then you should keep such variables. Those are impactful. If the p-value is greater than or equal to 0.05, you can safely drop those variables. These are not impactful. Okay. So go ahead. You are actually left with, from 8 features, you came down to 7 features. Do I need to check the p-value in 8 features, or do I need to check the p-value in 7 features when I'm doing the p-value test? Tell me. So one of the feature was dropped because it was independent. Do we really need to worry about that feature? It's gone. That feature is done and dusted. Okay. That will not be there in the model anymore because the information present in that feature has been copied, or there's a carbon copy of that information in another feature. That's why it's dropped. So we will be checking the p-value only in these 7 features. Go ahead, check these 7 features. Let me know, is there any variable whose p-value is greater than 5? So the question was, but we have the option of calculating p-value before VIF. Yes, if that is the case, you will start with 8. But after dropping on p-value, will you calculate VIF for all the 8 features? Think about it. Let's say based on p-value, you dropped one variable. When you come to VIF, will you include that variable while calculating VIF, or will you drop it? Think it that way. Are you getting what I'm trying to say? Vidya? Yeah?
Got it. Yeah,
Yeah,
thanks. Yeah.
So here, since we got rid of a feature, maybe if I come your way, you have dropped a feature that is not impactful. That's it. The end of the story for that feature. In the remaining feature, we check for the independence. Now we have gone with the independence first. Any of these 2 steps can be done first. Anything can be done next. Based on the independence, on those grounds, I dropped a feature. In the remaining 7, I am checking the impact. Go ahead, all of you. Check the p-value of every feature and then find out, is there any feature that is having more than 0.05 p-value? Monthly bill has a p-value of how much? Kanishka, I'll come to that question right after finishing this. Okay. Monthly bill has a p-value of 0.3, which is greater than 0.307, which is greater than 0.05. So this can be dropped. So from 7, we will come down to 6 features. So we need to look at a p-value for finding out the features that are. So on the ground of independence, we dropped one feature. Based on the impact, we dropped another feature. Out of these 7, one feature is not impactful. So the question is, how can we calculate the confusion matrix if there are odd number of features? You mean to say, if I go here, if right now we have 8 features, what if we have 7 features? How do we calculate confusion matrix? Is that the question? Would you like to expand it? So whatever is the number of features, you send all these features to model.predict, right? If you remember earlier also, we have only one feature, even one feature, two feature, three feature. No matter how many features are there, we send all this data to model.predict, it will give you the predicted value. Actual value is 0. Based on all the features, be it odd number, be it even number. Based on the features, you will get the predicted value, model.predict. Let's say logistic is the model, logistic dot predict, and you give the data x1, x2, x3. It is like a data frame. You don't give x1, x2, x3. You keep them in a data frame. Give the data frame as out input. Then you will get the predicted value, just a number 0 or number 1. That's it. Okay. So it doesn't matter how many features are there, be it even or odd or any number of them. Did I answer your question, or is there an extension of that question?
Um, Hi. So
Yeah.
actually, I tried to calculate the confusion matrix after dropping one of the variable with the 7 variables. So
Right.
I was getting an error that the expected number of variables are 8. So uh, while
So
giving
you have
7, it
you
was
rebuilt the model? Let's say you have built the model. So in that process, what happened was we discussed you have to drop this feature. After dropping this feature, have you rebuilt the model? Let's say you have built model 1, let's say with 8 features. Okay. And by looking at the p-value or VIF or something, we felt that one of the feature must be dropped. Then we just had a discussion that that will be dropped. Which feature is that? Some of the, like say, number of plan changes, this feature need to be dropped. After dropping this feature, have you rebuilt the logistic regression line? That is critical.
okay, got it.
After that, we can use that model. Okay. Yeah. Then the other question is, which order is better? First, going ahead with VIF, checking the independence, then coming into the impact. Is that order better? Which is p-value. Or first checking the impact, which is p-value, then checking the independence, which is VIF. Is this order better? Let me ask you a question. Let me answer this in form of questions. Let's say I checked VIF and I found that x1 and x2 are independent. These two are independent. Can I say anything about their impact? If two variables are independent, can I promise that they will be impactful? Or can I promise that they will be not impactful? Can we say anything about their impact? We cannot say, isn't it? Can I say these two are totally independent steps? No matter what happens here, it has nothing to do here, isn't it? Similarly, let me ask in some other way. What I did is, first I have done impact. I found that x1, x2 are impactful. This is impactful, this is impactful. Can I say anything about their independence? I looked at the p-value, less than 0.05 p-value. Impactful, impactful. Can we promising anything about their independence? Can we get any hint that x1 and x2 both are impactful? Definitely they will be independent. Can I promise like that in all situations? Really not sure, isn't it? That is the reason why whether you do this first, then go to this, or whether you do this first, then go to this. Since these two things are very, very independent steps, it doesn't matter which order we follow. Both the models will give you the same accuracy. Okay. So you can use this. In fact, the kind of complexity that is involved in doing the both steps is also same. We can do any of these two steps. Okay. There is no particular order even in the industry. People have to follow that rule. There is nothing like that. So we can do independence first, then go to impact, or impact first, then go to independent. Doesn't really matter. Both the models. In fact, you can take a particular model and follow these two procedures. You will get a model that will be having exactly the same accuracy at the end of the day. Now you have started with 8 features. 7 features are left after checking the VIF. 6 features are left after checking the p-value. Now there is one thing extra that you can do in logistic regression. This particular measure is not possible in linear regression, but in logistic regression there is one extra measure that you can make use of. What is it? Right now you have 6 features. Remember, all these features are impactful, which means all of them are independent and impactful, which means they're all important. Let's say x1, x2, x3, x4, x5, x6. These are the 6 features that are left finally. Now, is there a way I can rank order these? Out of these 6, what are the top 2? If you ask me, what are the top 2 variables? Can I rank order these and say x4 is the most impactful, followed by x1? These are the top 2 variables. Any change in these, your attrition will be very much impacted. Any change in this, your target variable will be very much impacted. If you want to see any change in the target, make changes in these top 2 variables. Rest of them will follow. Rest of them have slightly lesser impact. If I rank order the impact, rank order based on the impact of these features based on the target, upon the target, which are the variables that are having the top most impact? What is the use of this? You can always suggest business that it is impossible to improve everything. It is impossible to improve all the features. Budgets are limited. If your budget is limited, at least focus on those 2 factors. Put all the budget on those 2 factors. Immediately you may see an impact on the target variable Y. So is there a way you can suggest or you can rank order? Rank order, all of them are impactful variables. Rank order based on impact and write down what are the top 2 or top 3 variables. Rank ordering the impactful variables. This rank ordering of the impactful variables is not possible in linear regression. In logistic regression, you can use a measure called Wald chi-square value. Wald chi-square value. Wald chi-square value is not given in the output. Wald chi-square can be estimated by looking at the z-square value. Z is given in the output. You calculate the z-square, that is the Wald chi-square value. Higher the Wald chi-square, higher the impact. Higher the Wald chi-square value, there is a statistical measure called Wald chi-square. Higher the Wald chi-square, higher the impact. Remember, there is an important point here. Sometimes a variable is positively impactful on Y. Sometimes a variable is negatively impactful on Y. Always negative doesn't necessarily mean that it is a not impactful variable. It is impactful, but it is negatively impactful, which means as this variable increases, the Y variable may decrease. It's like that. Negative impact doesn't necessarily always mean wrong impact. There can be strong negative impact is a stronger impact versus weak positive, isn't it? Weak positive versus strong negative. Strong negative impact is higher impact, isn't it? The positive or negative sign is based on the type of the variable, based on the nature of the variable. Some variables are positively impacting, some features are negatively impacting. Sign will only tell us whether what is the type of impact, but what we want to look at is Wald chi-square to tell us which variables are impactful. Rank ordering. So you have 6 features, all those 6 features are impactful. First of all, you have to accept and understand the fact that feature 1, feature 2, all of them have passed the test of p-value. All of them are impactful. I'm not saying that they are not impactful. But what are we doing here? Within these 6 impactful, I want you to tell me top 2. Tell me top 1, top 2. Tell me these 2 features. Go ahead. Look at the Wald chi-square value, which is estimated by looking at the z-square. Z value is given to you. Look at the z-square. Tell me number 1 and number 2. So the first one, without any doubt, that will be number of complaints. The second one, what is the second variable? Speed test result. Look at the number of complaints. As the number of complaints increase, attrition increases. That's why there is a positive sign. But as speed increases, what happens to attrition? As the speed increases, if you are giving better and better speed, what happens to attrition? Attrition reduces. If the speed decreases, if your internet is slower and slower, if you are giving poor services, then attrition increases. It has a negative impact, but it has a strong impact. That's why these two are the top two variables. So what you can tell business partners is, you can build a model, you can always get the predictions, whether this customer will attract churn out or not churn out. That anyway you will get by using my model. You supply all the features of the customer, estimated income, number of complaints he has raised, what is the speed test in his area, number of service plan changes he has done, whether he is relocated or not. If you enter all these details, you can predict whether this customer is going to churn out or not. That prediction you can make. But if you want to work on it, if you want to build a strategy to reduce the attrition, there are two factors that you must focus immediately. The first factor is number of complaints need to be reduced. Number of complaints need to be reduced quickly. That is the first thing you should focus on. Maybe your service is not good. That's why this has a very highest impact on the attrition. Speed test. People are not satisfied with your speed. Maybe this is easy to address. Increase the server, etc., etc. Increase the infrastructure. You can increase the speed. Attrition will be reduced. Try to reduce the number of complaints. As soon as a complaint is raised, you have strict SLAs. Maybe within 12 hours, the complaint should be closed, or within 6 hours, the complaint should be closed. Have you observed some companies are very strict about it? Have you observed some companies, as soon as you raise a complaint, in fact, the field engineer will be in a hurry to close the complaint rather than resolve it, isn't it? Because that company is having very strict SLAs to the, those outsourcing employees which are working as field engineers. This is one extra that you can do in Logistic. It is kind of optional, not necessarily that always you have to give this. Only when somebody is building a strategy, you can suggest this. But the rest of the steps are mandatory. So these are the steps that we have to follow while building a logistic regression line. I'm going to list down all the steps once again. But before that, I would like to take the questions from you. Are there any questions? Z square. So here, if we come to the individual impact of the variables, so we started with 8 features. Out of these 8 features, based on the VIF, we came down to 7 features. Because one feature was kind of copy of the information. From here, based on the p-value, we came down to 6 features. Imagine these are the 6 features, x1, x2, x3, x4, x5, x6. These are the 6 features. All of them are impactful. Let us suppose we want to reduce the attrition. For reducing the attrition, we have allocated some budget. By improving these 6 features, by working on all these 6 features, we will be able to reduce the attrition. However, usually budgets are limited. Obviously, if you do the whole business in a better way, you will be able to reduce the attrition. But the thing is, budget won't allow. So what are the top 2 or top 3 features within this list? If I want to rank order, that means all these 6 features are impactful, that is given. Within this, if we want to rank order, is there any measure? Is there any measure that will tell me out of these 6, which is the most impactful? The rank ordering can be done using a statistical measure called Wald chi-square value. There's a formula which we calculated, which is calculated for every variable. Wald chi-square is calculated using z square. Z value is calculated for every variable. Based on that, we can rank order them. And say if the highest value of z square. In our example, the z square is highest for a variable called number of complaints. Next highest z square is speed test. So out of these 6 variables, we can say these are the 2 variables which are having the highest value of z square. These are the variables that are most impactful. That's what this z square is going to tell us. Any other connected questions, anybody? So the question is, even if it is negative, so impact. So let us think about, does negative value always wrong or right? Let us suppose x1 is positive impact, some other variable is negative impact. Does negative impact always mean less impact? Let us think that way. Let's say x1, there are few variables. There's a weak positive impact. There's a positive impact, but that is weak versus strong negative impact. In terms of impact, that means any change in this variable, which is having a strong negative impact, will have an immediate impact on the target variable y, isn't it? So that is why when we are looking at the impact, we don't really need to care about the sign of the variable. Why? Because impact is impact, whether it is positive impact or negative impact. If it is positive impact, any increment in this will definitely increase y. If it is negative impact, any increment in this will very surely decrease y. Whether the sign is positive or negative depends on the nature of the variables. Depending on type of the variable, we will get the sign. In our example, number of complaints. Now, if that number of complaints increase, attrition increases. That's why it has a positive sign. Whereas speed test, if speed increases, if you are providing faster internet, the attrition reduces actually. If the speed decreases, if you are providing slower internet, attrition increases. That's why it has a negative sign. However, it is strongly impacting. Negatively strong negative impact. That's why no matter what is the sign, it depends on the nature of the variable, but we must be considering the impact. All right. Let us write down the steps in building the logistic regression line. As usual, the initial steps will be the same. What are the initial steps? What is your model objective? What is your target variable? What are the features? Do you have the data? Do you need to buy the data from bureau? Have you collected the data? Data exploration, data validation. Have you found any outliers? Have you found any missing values? Outlier treatment, have you done it? All those steps will be common. After that comes the model building. Remember the data sets that I'm giving you, I have actually cleaned all that data. Originally, we must go through data cleaning as well. But what I thought is in every session, if we are spending a lot of time on data cleaning, we are going to miss the important point. Like the discussion in this session is the key point is logistization. Since we have to focus on that, that's why I'm giving you fairly cleaned data. And we learn data cleaning only in one step. When you are working on real projects, maybe for every project you have to do the data cleaning. In the classroom, only for one project we did the data cleaning. For the rest of the ones, I am giving you fairly cleaned data. Okay, because in every example, if we keep on cleaning the, if we're repeating the same thing, it's not going to be really helpful for us from the learning point of view. In which scenario do you even come to logistic regression? Tell me. In which scenario do you even prefer this logistic regression? when the output is classification or class, it is not continuous. In that case, you will come to logization. As usual, build the model by using all features. Don't miss any of the features in the first go itself. Right after building the model, next step is what? Right after building the model, we must do model validation. Do the model validation. Model validation here is done using R square value. What is a good R square value? How do you do model validation? R square? Is there any R square in association? Nope. We'll be creating confusion matrix. No R square, isn't it? Will you validate a logistration line using R square? Nope. Create confusion matrix, from there derive the accuracy. After that, what do we do? Accuracy must be above 80%. After that, what do? We check whether the variables are independent or not. Look at the VIF value. VIF less than 5, independent, keep them. If greater than or equal to 5, dependent, drop them. After that, what do we check? Drop sequentially. Drop in a sequence. After that, we look at the P value that will tell whether individual variables are impactful or not. Less than 0.05. Keep them, they are impactful. Greater than or equal to 0.05. Drop them, they are not impactful. There is one more extra thing that you can do. Once you have filtered out all the features, once you have all the features that are all impactful, what is the next step? Look at the walled chi-square value. Use the walled chi-square value to rank order features based on their impact. Use walled chi-square value to rank order the features. These are the steps you must follow while building a logistic regression line. Sixth step is optional. The remaining steps must be followed when you are working on any classification project and if you are solving it using logistic regression line. All the risk models in this world, risk models, CIBIL score and all that, all those risk models, we will be predicting whether the customer is defaulter, which is like 1, non-defaulter 0, okay, or a good customer. All the risk models are logistic regression models only across all the banks, be it Citibank, be it Bank of America, be it JPMC Bank, HSBC Bank. All the banks use logistic regression models. Then you will get a probability of default that is converted to a score. So that is the story of logistic regression line. It's most of the things will be matching from linear regression, this VIF, P value and all that. That's why we spent a lot of time on linear regression. But one striking difference is it is a classification problem. It's a classification algorithm. And let me tell you, in my experience, 90% of the problems, 90% of problem statements in this world are classification only. The companies are not really interested in point prediction. The industry is not really interested in point prediction. They are interested in either this side or that side. That is sufficient. Whether the customer is ours or not, that's it. How much is the wallet size? How much we can, how much revenue we can make? How valuable is the customer? Nobody is really bothered about it. Is the customer mine or not? That's it. Once the customer is mine, we can squeeze him later on, isn't it? First, get the customer on board somehow, quickly. Right? Any questions, anyone? Today we will take a slightly early lunch break because the next topic, if we start now, we have to close like end abruptly. Is it okay if we take a lunch break now, meet at 1:30? Is it fine? Yeah, because it will perfectly suit our discussion. So let us take a lunch break now. Let's meet at 1:30. Take a good break. And then decision trees and segmentation is upcoming, which is another interesting topic. We have another interesting case study in that as well. We're going to work on that. Okay. Let's meet at 1:30 p.m. I'll see you on the other side. Welcome back, everyone. Once you are back at your desk, send me a message. Until now, we discussed two major type of problem statements. One is regression type or linear regression specifically. The other one is classification type of problems. In classification type of problems, we have seen one algorithm called logistic regression. Since classification type of problems are very frequent, very usual, there are other algorithms as well for a particular type of problems can be effectively solved. Instead of using logistication for a particular style of problems, if we use decision trees, are they give us slightly decision tree gives us slightly better results when it comes to classification for a certain type of problems. Okay, not all problems. There are certain type of problems where decision trees are much more useful. Those problems are known as segmentation problems. They also fall under kind of classification. Let us see what are decision trees, etc., etc. At the end, I'll give you a comparison between logistic regression and decision trees. I'll also tell you which type of problems you should prefer logistic regression and what type of problem statements decision trees are much more suitable. We're going to discuss that as well. But before that, let us get an understanding of decision tree. Decision tree is a classification algorithm, so the business problem remains the same. I have a data set. In that data set, I have the gender variable, I have another variable x2, and I have the target variable y. What is this target variable? Whether the customer has ordered a product or not. Okay. 0 means he did not order the product. 1 means yes, the customer has ordered the product. Okay. And I have variables x1, x2. What is the idea here? As usual, I want to build a model. This model should help me in prediction of this. When a new customer comes in, customer 1, I want to predict whether this customer will really order this product or not. Yes or no. Customer 2, whether this customer will order the product or not. Yes or no. This is what I want to predict based on this data. The model has to learn the patterns from here and then give us the predictions. Here I'm showing you a smaller data set. The same thing holds good for thousands and thousands, millions of records also the same thing. Here is the decision tree philosophy. You know what decision tree tells us? Don't look at the whole data as one group. Don't look at the whole data as one group. You just simply rearrange the data in the form of a tree. Rearrange the data in the form of a tree. Surprisingly, once you rearrange the data in the form of a tree, you will be able to get these predictions very easily. You will also observe, if you look at the whole data, we cannot predict what is this person going to do, what is this person going to do, order the product or not. That we cannot tell. Whereas, if we rearrange the data in the form of a tree, we ourselves will be able to make these predictions very easily. Let us rearrange the data in the form of a tree. There are 14 records here. Imagine these are 14,000 records. 14 records. 10 are non-buyers, 4 are buyers. Overall, there are 14 records. 4 customers have ordered the product, buying the product, purchased. Remaining 10 did not purchase. No is 71% in the whole data. Yes is 29%. Do you have the information on the gender? Yes, I do have the information on the gender. Divide the data based on the gender. There are 8 male customers, 6 female customers. Within 8 male customers, 7 are not buying, 1 is buying. Within 6 female, few are buying, few are not buying. Just by simple counting, we can get to know that. Within male, how many are buying? Within female, how many are buying? We can get that. Do you have the information on marital status? Yes, I do. Further divide them. Further divide them. Within male, 6 are married. Some of them, none of them have purchased. Within male, some of them are unmarried, purchased and non-purchased probability. Within female, 3 are married. None of them have purchased. Within female, 3 are married. All of them have purchased. So what did we do? We took one data set. We divided it into subsets. Subset 1, segment 1. Subset 2, segment 2. Segment 3, segment 4. Instead of looking at the data as one group, we have divided it into 4 subsets. That's what decision tree tells us. You divide the data into 4 subsets. And you can get the predictions easily. Customer number 1. This customer has logged into your website. From his profile, you got to know he is a male customer, married as well. Is this customer going to order the product or not? Yes or no? Can you guess it, or it is totally not possible to guess? Tell me, is this customer going to order the product? Think about it, all of you. Try to participate kindly. Is this customer going to order the product or not? This customer is not going to order the product. Customer number 2, as soon as this customer logs in, you got to know female customer, unmarried. Is this customer order the product or not? There's a high chance that this customer will order the product. How did you come to know this? Some of you are giving the answers. What about, how did you do that? Those who gave the answer, you know what, how did they think? When I said male customer, male, married. Historically, most of the male married customers did not purchase. There's a high chance that this customer will also not buy. It may happen that he may end up buying, but there is a high chance, our prediction will be that this customer has a very low chance of. Female unmarried customer, female unmarried. Historically, most of the female unmarried customers have purchased. It all depends on the type of the product. Historically, what we have seen, most of the female unmarried customers have purchased. So there's a high chance that even this customer will purchase. That's what decision tree tells us. Decision tree tells us, don't look at the whole data as one group. If you look at whole 14 records as one group, then it is impure. Impure means both the classes will be there. Both the classes are present in the whole data. Class 0 is also present. Class 1 is also present. If both the classes are present, then it is known as impure set. Divide the data into subsets which are pure in nature. This is pure set. 6 out of 6 are non-buyers, pure non-buyers. This is a set where there are 3 customers. 3 out of 3 are non-buyers. This is also pure non-buyers. This is pure. 3 customers are there. 3 out of 3 of them are buying. Pure buyers. What about this one? Is it a pure set or impure set? 2 customers are there. One is buying, one is not buying. Can I say this is a pure set or is it an impure set? That means if a customer is male, unmarried, can I really decide anything? Is he going to buy or not buy? If a customer is male, unmarried customer, is he going to buy the product or not buy the product? Or we cannot decide. What do you think? This is an impure set. So if something is impure, if somebody falls in impure set, be able to decide, isn't it? Overall data is impure. We have divided this data into maximum amount of pure subsets. This is pure. Obviously 100% we cannot do this. Pure, pure, pure. This is still impure, little bit of part is still impure, but we have achieved purity at most of the subsets. That is what decision tree tells us. Decision tree tells us that take the whole data, don't treat it like a single data set. Divide the data into segments that are pure in nature. What do you mean by purity? If I say this bar is a pure gold. If I say this is a pure gold bar, what does that mean? Purity means what in general? Pure gold means what? The whole bar is 100% gold. No mix. Yeah, that is an easy way to think about it, isn't it? There is nothing mixed. There is only one class. There is no mix of classes or anything. Purity means only one class is dominating. Okay. If I say this is pure gold, that means there is no bronze mixed or anything. This is totally gold. When I say this bar is impure, means what? There is gold plus some other metal is also mixed. Okay. So we want pure subsets. From impure data, we want to make pure subsets. If you have pure subsets, then your decision making will be easy. The prediction can be made easily. That is the whole philosophy of the decision tree. However, there are few unanswered questions. There are few questions that come to our mind. Question number 1. First question that comes to our mind, or that should come to our mind, is you have two variables, gender and marital status. Why did you use gender here, then marital status? What happens if I use marital status here and then gender here? Why didn't I use that? Is it a random selection? Is there a logic behind it? Which means if we have variable x1 and x2, which one to choose first for splitting? Isn't that the first question that comes to our mind? If you have two variables x1 and x2, which variable will you use for splitting? Question number 1. Question number 2. Here you have comfortably used a small data set with two variables, but in reality I have variable x1, variable x2, variable x3 and so on, variable 30, 40, xk variables are there. Out of these variables, which variable I should use here? By default, is it always the first one? Is it the second one, or is it the kth one? After this, which variable I should use here? Which variable I should use here? When you have so many variables, which variable you should use for splitting? These are the questions that will be answered by the decision tree theory, which we are going to discuss now. Once we answer these questions, then most of the decision tree part will be almost understood. So let us try to answer these questions using the decision tree. But overall, philosophy wise, what decision tree is trying to do, dividing the data into subsets. Overall, philosophy wise, are you fine? Have you understood what decision tree is all about? Decision tree tries to take the whole data, divides it into subsets. These subsets need to be pure. Once you have achieved pure subsets, if a customer falls in that, they easily you can actually predict whether he is going to be class 0 or class 1. Now let us answer question number 1. What is the decision tree theory that will try to answer this first question? Let us suppose you have two variables. You have a data set. Let us suppose the data has 100 records. 50 of them are class 1. 50 of them are class 2. Class 1 is, let's say, buying the product, purchasing, and not purchasing. You have two variables. Income is one variable. Gender is another variable. X1, X2. Now you can split this data into two parts based on income if you would like to. You can also split this data based on gender. Which variable I should use when I have two variables like this? Let us see what is the result. If I split based on income, this is scenario 1. Let us split based on income. 100 customers are there. 50 are buying, 50 are not buying. Let us split the data based on income. There are 60 customers who are lower income, 40 customers who have high income. Overall, buying and not buying is 50-50. In low income segment, buying and not buying is almost 50-50. In high income segment, buying and not buying is almost 50-50. This is what happens if I break based on income. Alternatively, I can also divide based on gender. I take 100 records, 50 are buying, 50 are not buying. There are 60 customers who are male customers, 40 customers are female customers. Out of 60 male customers, 48 are buying, 12 are not buying, 80% are buying, 80% of the male customers are buying, 20% are not buying. Out of 40 female customers, Only 2 are buying, only 5% are buying this particular product that we have. It depends on the product also. 38 are not buying, 95% are not buying. Now, you can divide based on income, you can divide based on gender. But given a chance, if I ask you to use only one out of these two, which variable will you use for splitting first? What is the beneficial variable? Which variable gives you better result, better decision making ability? Splitting on which variable? Is it income, which is a better split, or is it gender that is doing a good job of splitting? Everybody is saying gender, gender, gender. It's the right answer. Why gender? Why not? What is that you did not see in income? What is that speciality about gender here in this example? What was your thought process? Why did we pick gender? Before splitting based on income, if I ask you whether this person will buy or not buy, you'll say, I can't say, or almost 50-50. After splitting, if I tell you a customer has low income, is he going to buy or not buy? What will be your answer? Still, I can't say, or 50-50. This is also 50. This is impure. Before splitting, we expect the data to be impure, fair. But after splitting, even after splitting, we expect the data to be impure or pure. If a variable is good, what it should give us? If a variable is good, after splitting, it should give pure subset. But income has given impure set here, somewhat impure set here, 50-50, 50-50, 50-50. Whereas gender, I'm not saying this is 100% pure, somewhat pure. Okay. This is also, out of all the 4 segments, this is the best purity. Pure non-bias. Purity will help me in decision making easily. Gender is giving me purer subsets rather than income. So if you have 2 variables here, visually which variable are you going to choose? Gender is the variable that you're going to choose. What I'm going to do right now is I'm going to define a measure. It will quantify what is the impurity reduction. Income did not do a great job of reducing the impurity, whereas gender has done a great job of reducing impurity, or in simple words, gender has increased the purity, income did not increase the purity. It's almost same. So we are going to quantify the reduction in the impurity. First, let us define what is impurity. Let us quantify the impurity in a given set. Entropy is the measure of impurity, diversity, randomness. If you have a set, you can measure the impurity using a measure called entropy. Entropy is calculated for a set S equal to minus P1 log of P1 minus P2 log of P2. What is P1 and P2? If you have a set, let's say if you have 100 records, P1 is probability of class 1. P2 is probability of class 2. So 0 and 1 are the ones. Let's say if you have 50 customers, 100 customers, out of them 50 are buying, 50 are not buying, then P1 is 50%, P2 is 50%. If 40 are buying, 60 are not buying, then P1 is 0.4, P2 is 0.6, like that. Okay. P1 is probability of class 1, P2 is probability of class 2. If you have, let us suppose if you have a set, in that set 100 customers are there. Can you make a guess what value of P1, what value of P2 constitute to the most impure set? When do you say this is absolutely impure? Nothing is, decisive about it. What value of P1, what value of P2 will constitute to the impure set? In a set, 100 records are there. What's the P1 and P2 value out of 100? What should be P1, what should be P2 for you to tell that, yeah, this is totally impure. I cannot really decide anything. Totally random. When do you say it is totally random, totally impure, very, very diverse set? When P1 is 50, which is like 0.5, 50%, which is like 0.5. P2 is also 0.5. This is like 50 records are of class 1, 50 records are of class 2, plus and minus. Then you would say that this is totally impure. Apparently, if you put P1 0.5 here, P2 also 0.5, you will get the entropy value as 1. Entropy, measure of, whenever you see entropy, you see that measure of impurity, measure of diversity, measure of randomness in a system. Entropy highest value is 1. 1 can be achieved when you have P1 equal to 0.5, P2 equal to 0.5. It is the most impure set. Entropy highest value is 1. Let us suppose you have 100 records. Let me ask the opposite question to that. If you have 100 records, when do you say I have a pure set with me? All these 100 records are pure. In which scenario? What is the value of P1? What is the value of P2? That will give you a pure set. P1 out of 100, all the 100 are buying. None of them is not buying. P1 is 1, like all the 100 are buyers. That is one way. Is it the only pure one? Or is there any other way of looking at purity? Purity means only all pure buyers. That is a pure set, that I agree. Is there any other scenario that can also be called as pure? Think about it. 100 customers are there. All these 100 customers are pure buyers. That is one level of purity, which will be very, very decisive. I can take a decision easily. What is the other level of purity? What is the other level of purity? Think about it. That is P1 is 0. That means all pure non-buyers. P2 is 1. Either 1 0 or 0 1. In both the cases, if we put P1 is 1, P2 is 0, or P1 is 0, P2 is 1. In both the cases, you will get entropy to be the least value, because entropy is a measure of impurity. But purity, if it is a pure set, entropy, impurity is 0. Entropy varies between 0 to 1. It happens when you have P1 0, P2 1, or 1 0. In this case, entropy will be 0 for pure sets. When this will happen, P1 is 0.5, P2 is 0.5. Entropy is a measure of impurity. Tell me one thing, at the end of the day, what kind of segments are beneficial for you? Low entropy segments or high entropy segments? What kind of segments are you looking for at the end of the day? What are beneficial for us? Low entropy segments are going to help us in decision making, or high entropy segments are going to help us. Think about it, everyone. What do you think, in your opinion, what kind of segments are beneficial for us? The segments that are having low entropy, low impurity, low diversity, which means high purity. We would like to have low entropy segments, isn't it? Low impurity. Let us do the calculation and see that. Okay. Let us do this exact entropy calculation. We are going to anyway do this lab exercise, but before that, okay. In practical cases, can it be 0? Yes. When P1 is 0 and P2 is 1. If not all the segments, there can be some segments, it can be 0. You mean to say, is it impossible that it will never happen? That's not true. It can. But will it happen frequently? It may not. You may not see frequently. Okay. So we cannot totally write it off. But 100% purity in general cases, in general, we may not see. Okay. But I cannot say that we will never get a 0, that we will. Okay. Got it? Let us suppose if I have a segment where P1 is 0.5, P2 is 0.5. What is the expected value of entropy that you will get? How much is the expected value of entropy? It will be actually 1. We will do the exercise and we will realize it. If P1 is 0, P2 is 1. What is the expected value of entropy? P1 is 0, P2 is 1. Expected value. Tell me the third one. P1 is 0.45. Carefully think about it. P2 is 0.55. Entropy, will it be near to 0 or will it be near to 1? Will this be near to 0 or will this be near to 1? If the scenario for a segment it's like this. Whereas this will be near to 1. P1 equal to 0.05, 5%. P2 is 0.95, 95%. 5 versus 95. Entropy. will be near to 0 or near to 1? It will be near to 0 or less than 0.5, isn't it? For sure. Let's go to the code file and see the actual values. We will go to our Google Classroom, classwork, decision trees, decision tree code. I'm going to paste this link in the chat window. Tell me the actual values here, entropy values. After calculation, what are the values? Entropy 50-50 case would be 1. Since log 0 is not defined, we will put 0.001, 0.999. Entropy will be 0.00, which is nearly 0. 45-55 case would be 0.99. 595 case 0.28. These are the entropy values. Once you are done with this part of the exercise, send me a message, then we'll proceed. Okay. Now that we understand the concept of impurity, now we will see how a variable does a good job of reducing the impurity. After splitting, impurity should be reduced. So the next measure that we are going to discuss is the one that will decide. So you have segment 1, segment 2, segment 3 examples where P1 is nearly 0, P2 is nearly 1, then entropy will be lesser. Segment 12, segment 13 where P1 is near to 1, P2 is near to 0, then entropy is lesser. Versus you have segment 7, segment 6, segment 8 where entropy is near to 100% or near to 1 when you have 50-50, 40-60, 60-40 like that. So what kind of segments are beneficial for us? The segments either P1 is near to 0 or P2 is near to 0. Those kind of pure segments are required for us. So how do we choose a variable that can make us or give us these pure segments? So the next measure is information gain. This is the last formula. Once we understand this, then we are through. Very simple formula. Information gain is calculated for a feature. Information gain is nothing but entropy before split, impurity before split. So you have this segment. Before splitting, what is the impurity here? After splitting, what is the impurity here? What is the impurity here? Before splitting, I can expect more impurity. But after splitting, the weighted impurity has to be lesser. So how do we calculate entropy for a given variable, for a given feature? Here is the process. Entropy before split minus entropy after split. So if we take the previous example, income was one of the variable, gender is another variable. Already all of us picked gender is a good variable, but now what are we doing? We are going to quantify it because general visual inspection is good, but we have to put it in a model. Mathematically, we have to quantify it. Information gain equal to entropy before split minus weighted entropy after split. Let us come to this segment. P1 is 0.5, P2 is 0.5. You have already calculated it. If I calculate entropy, how much will I get for this segment? If I calculate entropy, how much will I get? I'll get it as 1, which is like 100%. 100% is the entropy. If I come to this segment, P1 is 0.52, P2 is 0.48. Can you make a guess for this segment if I calculate entropy, how much will that be? For this segment, if I calculate entropy, how much will that be? Will it be near to 1? Yeah, near to 1. If we calculate entropy, we will get it as 0.99, which is like 99% is the entropy. Impurity is still high. For this segment, P1 is 0.48, P2 is 0.52. For this segment, if I calculate entropy, how much will that be? Near to 1. Here also near to 1. If I calculate, I'll get it as 0.99, which is again 99%. So information gain, which is also known as entropy reduction. Information gain for income variable is entropy before split 100% minus weighted entropy after split. 60 records are here, give the weightage accordingly. 40 records are here, out of 100, 60 are here, 40 are here. 0.6 into 99, 0.4 into 99. So information gain for income is 1% only, or entropy reduced by only 1%. That's it. Entropy was 100% on an average earlier. Now on an average, how much is the entropy? After splitting, on an average, how much is the entropy? On an average, right now entropy is 99. So there is not much of real use of splitting it based on income, because entropy gained is like information gain is just 1%. You come here to gender. This segment, P1 is 0.5, P2 is 0.5, entropy here is 100%. P1, not a perfect one at 0.8, P2 is 0.2. For this one, for this segment, entropy is 72%, not pure. P1 is 0.05, P2 is 0.95, one of the best. It will have the least entropy, which is like 29%. Information gain for the variable gender is entropy before split, which is 100%, minus weightage of this into its entropy, 0.6 into 72, 0.4 into 29. So information gain for gender is 45%. So we have reduced the entropy by 45%. Impurity was 100%. On an average, you can say right now it is around 60 or 65 or around that level. So information gain for gender is 45. Information gain for income is only 1%. So if you have two variables x1 comma x2, and if you don't know which variable to split, you're going to calculate the information gain of both the variables. And which variable are you going to use out of these two for splitting? Finally, which variable are you going to use? You're going to use that variable which has higher information gain. Higher information gain means giving us purer subsets. Earlier we have picked it visually. Now we have quantified it using information gain. Information gain is a critical measure. Entropy before split, impurity before split, minus average entropy after split, which means how much purer subsets a variable is giving after splitting, that matters. Now the second question is, if I have variable x1, variable x2, variable x3, and so on, variable x30, which variable I should use for splitting? Which variable I should use for splitting? I have 30 variables with me. Which variable do you want me to use for splitting? I will calculate the information gain of all the 30 variables. Then we have to use that variable which has the Try to participate. Calculate the information gain of all the 30 variables. Use that variable which has the maximum information gain, highest information gain. If we understand this, then decision tree algorithm is very easy. What is decision tree algorithm? Take the whole data as input, give the subsets as the output. Let us imagine a data set which has 10,000 records and x1, x2, around 20 variables are there. I have to split this data into two parts. Okay, two subsets I have to make. All right. Now, which variable I should use for making this data into two subsets? Is it x1, is it x2, or is it x20? Since x1 is first variable, can I use x1 here? Or can I randomly pick a variable? Which variable I should use for splitting here? Tell me. To choose that variable, we have to calculate the, what is that measure? Entropy further goes into information gain, isn't it? We have to calculate the information gain of all the 20 variables. Use the variable that has the maximum information gain. For example, let's say x15 is the variable that has the maximum information gain. Suppose that it is giving 6,000 records here, or let's say around 6,500 records here, 3,500 records are here. Is that it? Shall we stop here? This data is impure. We made it into somewhat pure. Do you think this is totally, completely bias here? Completely non-bias will come. Complete class 0 will come here. Complete class 1 will come here. Will it happen like that within one split? Do we get absolutely pure segments in one shot? Do we get like that? Do you think this one will be absolutely pure? This one will be absolutely pure? No. There will be still some impurity here, but this is better than this. It will be better than this, but still there will be some impurity, which means the problem statement that you have started, I have impurity, I want to make it into purer segments. The same problem statement you have it here. I have impurity here, I have to make it into purer subsets. I have impurity here, I have to make it into purer subsets. How do you take a data set? How do you divide it into purer subsets? Which variable you will use here? Which variable? To decide that variable, what we should do? To decide that variable on a given set, if I want to, like the way, like if you are here, when you were here, what did you do? You have used the variable that has the maximum information gain on this subset. You come here, recalculate the information gain of all the variables, x1, x2, and so on, x20 variables, but on this subset. Use the variable that has the maximum information gain. For example, x3 is the variable that has the maximum information gain. Okay. Let us suppose 5,000 records are falling here. 1,500 records are falling here. Come here. Can I directly assume that x3 worked as a good splitting variable? Can I directly assume that on this subset also it will work? Directly can I split based on x3? Or do you think we should recalculate the information again on this subset? What may work on this may not work on this. What do you think is the right option to do? What may work on this subset, there is no guarantee that it is good splitting variable here as well. So we need to recalculate the information gain of x1, x2, and so on, x20, all the variables. Use the variable that has the maximum information gain. Split this data based on that variable. Let's say 500 records are falling here. Around 3,000 records are falling here. Now when do I stop this process of growing? When do I stop it? Once if you reach a place, let us suppose these 1,500 records, if they are pure or almost pure. Pure means what? Almost all of them are of same type, class 0 or class 1. Then you stop that node, remaining will grow. The remaining will grow. If these 500 records, if they are almost pure, that means if the entropy is near to 0, almost 95% of that is almost one class. Purity means what? Purity. Pure means what? Impurity 0. That means entropy is almost near to 0, or one class is dominating. Once you have achieved purity, in this one you will stop. The remaining ones will grow. Okay, there are 1000 records here. There are 2000 records. This is the best stopping criteria. Once you have achieved purity, that will stop. Sometimes what happens? I haven't achieved purity. There is a chance for it to make it even further pure. Entropy is not near to 0, not even near to 0.1 or 0.2. Entropy is still high, but the thing is that I do not have the variable that can make it further pure, because this is better than this, better than this, better than this. So which means it is far better than the original data, but there is no way, there are no other variables that can make it further pure. Then I'll stop it. If this can be made into pure, I will grow it. 500, let's say this is 500 records, this is 1500 records. There is some impurity, but there is no variable that can make it further. There is some impurity, there is no variable. Usually this is the most prominent or most frequent stopping criteria, because there is no way we can expect 100% purity. We have impurity left, but there is no variable that can make it further pure. The power of the variables is not such that it can make it pure. So these are the final segments. We take one data set, divided it to segment 1, segment 2. Segment 1 is 3000 records, segment 2 is 500, segment 3 is 2500 records, segment 4 is 1500, segment 5 is 500, segment 6 is around 1000, segment 7 is around 2000. We have divided the data into 7 segments. Compared to the original data, all these segments are much, much purer. Every time you go to a next level, you are going to get the purity. That means your decision making will be easy. This is the whole decision tree algorithm. Once again, what is the decision tree algorithm? Let us see the actual real theory. Decision tree algorithm tells us that select a leaf node. Usually a leaf node is a node that is the terminal node, the last node. Below it, if there is nothing, that is known as leaf node. Several leaf nodes will be there. In the beginning, I have only one node, which is root node, which is full data. Select that root node. Find the best splitting attribute. Attribute means feature. Find the best splitting feature by calculating complete this statement. Find the best splitting feature by calculating what? By calculating the information gain value. Isn't it? Entropy further than information gain. Split the node using that attribute which has maximum information gain. Okay. Variable that has the maximum information. It will give you 2 nodes. Go to each child node. First go to this child node, then go to this child node. Repeat step 2 and 3. Find the best splitting attribute, split. Find the best splitting attribute, split. When do I stop it? What are the stopping criteria? If leaf node contains examples of one type, that means if entropy becomes 0, or if you have achieved purity, only you stop that node. Remaining ones will grow. If one leaf node attains purity, you cannot expect everybody to stop. Only that leaf node will stop. This leaf node, one achieved purity, that will stop. Algorithm ran out of attributes. You don't have any other further attributes. No further significant information gain. So here I have the variable, but just by splitting it, I am getting only 1% reduction, or just 0.1% reduction in the entropy. Then I don't want to do it. There is no point in just for the sake of splitting, we don't split it. If there is no further significant information gain, you can set that level. At least I want 5% reduction in the impurity. At least I want 10% reduction in the impurity. If there is only 1% or 0.1%, I don't want to do it, because almost impurity will remain the same. By following this algorithm, decision tree takes our full data as input. This full data is taken as input. It gives us the segment 1, segment 2, segment 3, segment 4, segment 5, segment 6, like these segments as the output. Though decision tree is a classification algorithm, it is specifically useful for customer segmentation problems, or in general segmentation. What do you mean by segmentation? Dividing the data into segments, especially in marketing. In marketing, this customer segmentation is a very prominent technique. If you talk to any marketing team, by default, they will be using these decision trees for doing the customer segmentation. Study this segment, apply a strategy that they can feel connected to. Study this segment, apply another strategy, apply another strategy, apply another strategy. Like that, for these 6 segments, 4 or 5 strategies can be derived. Instead of applying one strategy, instead of sending one SMS to everybody, what I can do is I can study each and every one of them, and I can give very much target customer focused type of marketing can be done, which will give best ROI. Decision tree is not only just classification algorithm, it gives us the output as segmentation. So when you have the problems related to customer segmentation, it's the most preferred one. That is the algorithm of decision tree. In reality, we don't need to do any of this. There will be a function. You supply the data of X, you supply the data of Y, that's it. That function will automatically take care of all these things. But why are we discussing this whole theory? We want to understand how that function is working in the background. How that function takes our input, gives us these segments. The process that function follows is this algorithm, the formulas it calculates. We will not get to see entropy. We will not get to see information gain. It's almost like nothing will be visible to us. We will directly get to see the output. Behind the scenes, all these calculations will happen very, very fast. Within fraction of seconds, we have the output ready in front of us. That is the theory of decision trees. Before going to the case study, I will take few questions from you. All right. Morning, we have discussed churn prediction model. I told you that is one of the important model. You may be working on that churn prediction model in future. There is one more model. There is a high chance that you may be working. That is customer segmentation model. What is customer segmentation model? You want to run some marketing campaign. Okay. If you want to run some marketing campaign in marketing, one of the most widely used phrase is one size doesn't fit all. One size doesn't fit all. You cannot apply one marketing strategy for everybody in your portfolio. That is very, very bad way of targeting people. What we need to do is we are supposed to divide the data into segments, study each segment, devise a particular marketing strategy for that segment. What a particular group of people, let's say if people are certain age range, from a certain gender, from a certain place, might be very different from a different gender, different age group, from a different place. What these people may like may be very different from these people. Let's say somebody who is living in Bangalore, who is a working professional software, whose age range is from, let's say, from 25 to 35, is very different from somebody who is living in some other place, something like Mumbai or Delhi, okay, who is not a software professional, he is non-taxpayer or something, okay, maybe some business he has, who is having an age group of 45 to 55. These two customers are very, very different. Same strategy should not be applied on those two customers. We have to give different strategies so that, like, at the end of the day, what we want to do is both of them should be coming back to buy something from us. That marketing strategy should hit them. That is why certain type of advertisement you don't see in all TV channels. There is a golf dedicated TV channel. Sometimes when I tune into that, I see only particular type of advertisements run there. You will never see those advertisements on any other TV news channel or anywhere else. You will not see them. Only in that particular channel you will see certain advertisements because they feel that that is their target customer segment. All right. So here is the model that we are going to build. The data that we are going to talk about has been given by one e-commerce company. So how do they do the customer segmentation and how do they target the customers is what we are going to discuss. So historically, this e-commerce company has collected some survey data. Sometimes they take direct surveys, sometimes they take indirect surveys based on our click stream. They will gather some information without our permission or based on the mobile phone app. On the app, when you are doing something, most of it gets tracked. Okay. So what they have is around 11. This is a direct survey result. The customer is aware of it. He is very much conscious of what is he is doing. So we have data like customer number. Around 11,805 customers participated in that survey. Customer region. We know customer region is from east or west or north or south. Customer age. Customer order quantity. Previously, how many orders he has placed. Customer type, prime or non-prime. Overall satisfaction. This is my target. Whether the customer is satisfied or dissatisfied. What we want to do is based on this, we want to do the customer segmentation. I want to predict whether the customer will be satisfied or dissatisfied even before he takes a survey. Without even taking the survey, we want to get to know what type of customers are satisfied, what type of customers are dissatisfied. Is there any corrective action that we can take? It's almost like customer experience management. Okay, let us understand this data. Let us see how decision tree helps us in building the customer segments, dividing this whole 11,000 customers into groups, not necessarily equal groups, but necessarily the groups that are similar to each other. They should fall in one place. How do we divide that into segments that are pure? Okay, that will help us in our decision making easily. Usually I clean the data, I give you the cleaned data. Here I have kept few things open so that I want to make actually a little bit of note here. Customer type is a string object. It takes two values, non-prime and prime. Overall satisfaction is a string object. It takes satisfied and dissatisfied. Before building the model, we are supposed to map them onto numerical values. I have mapped prime to 1, non-prime to 0. It is okay if I have mapped prime to 0, non-prime to 1 also okay. Maybe one customer, one of us will get a decision tree, prime this side, non-prime this side. If we do the opposite of it, mapped this to 0, this to 1, we'll get N here, P here. The results won't be different. One tree will be simply the mirror image of other one. So customer type is the column. I'm going to customer type. Wherever prime is there, I'm keeping number 1. Wherever non-prime is there, I'm keeping number 0. This whole data as an integer, I'm storing it in a new column called customer type num. This will be used in the model. This will not be my feature. This is the feature that will be used. Overall satisfaction, dissatisfied map to 0, satisfied map to 1. It doesn't really matter which one is 0, which one is 1, because later on we are going to identify. Let's say if I map dissatisfied as 1, the count of ones will be called as dissatisfied. Here we are mapping it to 0 and 1. Doesn't really matter. Any one of them we can map. That is the simple data pre-processing required. After that, my features or the X variables are region, age, X1, X2, order quantity, customer type. Customer type num is the new column. Overall, there are 11,000. So I'm going to create X data set from e-commerce. Take only these 4 variables, put it in a matrix called X or put it in a data frame called X. X shape will be 11,805 rows are there. And how many columns in X? In X, how many columns will be there? How many columns? 11,805 rows and 4 columns. Y will be, there is only one column, which is like e-commerce data overall satisfaction. This will have 11,805 rows, comma, 1 column. This data will be used in model building. The model building is pretty simple. In fact, all the model building part of the code is just 2 lines of code. In the whole machine learning, that is the pattern, common pattern. Model building is 2 lines of code. Model configuration, model.fit. Always this is just the 2 lines of code. Here is the first line. Tree.decision tree classifier. And we gave an extra parameter called max depth. This is an important parameter. Make a side note of it. Make a note of it. We are going to discuss it little later. We have to discuss this in depth. I'll come back to this. As of now, you think this is a syntax only. D tree equal to tree.decision tree classifier. For some time, ignore this value. Decision tree.fit model. Declare the model. I'm going to build. Earlier we declared logistic regression, linear regression, like that. Now we have declared a decision tree. Decision tree.fit x comma y. X data, all the features. Y data, target variable has been given. Once you do this with this one line, the whole decision tree algorithm will run. What is the decision tree algorithm? Try to recollect what is the decision tree algorithm. Take the root node and then find the variable that has the maximum information gain. Divide the data based on that node and then go to the each child node. Calculate the information gain of all the variables. Use the variable that has the maximum information gain for splitting. All that process, stopping criteria. Once you have achieved purity, then you stop that node. Rest whole thing will happen once you say fit. Within a fraction of a second, that whole decision tree will be created. Information gain will be stored. All the values will be stored. Which node has how many records will be stored. Everything will be stored in an object called decision tree. This is the model object. It has all the information present in it. Okay. What we will do is there is a function called plot underscore tree. If we say plot underscore tree, to that, if we give decision tree as input, the model name, whatever is the model name, my model name is D tree. If my model name would have been D tree underscore model, we'll mention model here. And then give what is the output figure size and all those things, some basic options. But this is the important one. Give this plot underscore tree, what it will do is it will print the decision tree for you. Or so correct way of saying it is plot the tree. Plot the decision tree for you. Then we have to interpret the decision tree and do the further analysis. We are going to do the interpretation after creation of the tree. First, all of you, step by step, step by step, step by step, snippet by snippet, snippet by snippet. Start with data importing, followed by pre-processing, followed by X and Y creation, followed by model building and creating the decision tree. Go ahead, create the decision tree. If the decision tree is in front of you, send me a message. If everything works fine, the decision tree will be in front of you. Let's wait for everyone to complete this. Just waiting for a couple of people to confirm this to me. Are you still doing it? Are you done with this? If everything works fine, you will get this decision tree as the output. Let us see how to read the output from this decision tree. Since there are too many values, it may be confusing sometimes. So we have to read it in a particular manner to avoid all the confusion. So the first thing is samples. Samples is nothing but number of records. This root node is full data. Full data has how many records? 11,805. How can I verify it? If I go to the data, there are 11,805 records. That's what it says. Number of records. In this node, how many records are there? 739. In this node, these many records are there. In here, 379, 7018, 475, 3933 records are there. Samples are the number of records. Is it clear? Wherever you see samples, will you be able to identify it? Samples is nothing but number of records. Anybody, any doubt on the samples only? Clear on samples? Next one. Value is the next one that you should read. Value is target variable y value. Target variable y value. Our target variable y takes two classes here. Satisfied and dissatisfied. Always target value, always zeros are shown first, ones are shown next by default. Value, target value, zeros and ones. It is always shown in the order of 0 is always first, 1 is shown next. Okay. For you, what does 0 mean? 0 means satisfied or dissatisfied? Can you go back to your code file and re-verify? Is a dissatisfied 0 or satisfied 0? Tell me. For me, how do I read 0 as? 6408 or dissatisfied or satisfied? How do I read it? How do I understand? What have we mapped 0 to? 0 has been mapped to dissatisfied. 1 has been mapped to satisfied. That's the reason why I'm getting 6408 which are dissatisfied, 5397 which are satisfied. What if I would have done the opposite while writing the code? What if I would have written satisfied is 0, dissatisfied is 1? What will be the difference in the output that I will get? Tell me. What will be the difference? Instead of showing 6408 5397, it will show always zeros first. That means 5397 comma 6408. The counts will be shown like that. So here we have mapped satisfied to 1, dissatisfied to 0. 6408 are dissatisfied. In this segment, how many are dissatisfied? In this segment, how many are dissatisfied? Here. In here, how many are dissatisfied? In here, 6374 are dissatisfied. 1033 are satisfied. The last one. In here, how many are dissatisfied? 4 are dissatisfied. 375 are satisfied. Is value also clear everywhere? Out of 11,805 records, these many are dissatisfied, these many are satisfied. Out of 379 records, 4 are dissatisfied, 375 are satisfied. Out of 475, 6 are dissatisfied, 469 are satisfied. Sample and value, are these two clear, everyone? Please let me know if there's any question on those two, sample and value. Yeah, perfect. Now when we gave this data to decision tree, to the decision tree we gave the region, we gave order quantity, we gave customer type, we also gave age, we gave x1, x2, x3, x4 variables. Decision tree will calculate the information gain of x1, x2, x3, x4, all the 4 variables. First it will come here, it will calculate the information gain of all the 4 variables. Okay, it will find out the variable that has the maximum information gain. Okay, and on the root node, whichever variable has the maximum information gain, it will be used for splitting. For our information, the variable that has the maximum information gain on the root node is shown inside the root node itself. Out of these 4 variables, the variable which has the maximum information gain is shown inside the root node itself. So tell me, on the root node, which variable has the maximum information gain? Which variable has the maximum information gain on the root node? All of you go to the root node. Go to the root node. Yeah. Try to completely forget about other nodes. Focus only on the root node. Tell me now, once again, which variable has the maximum information gain on the root node? Decision tree will show it to you inside the root node itself. Tell me which variable. Can you see the variable? The variable which has the maximum information gain. Decision tree has calculated the information gain for region, information gain for order quantity, information gain for customer type, information gain for age. It found that the variable that has the maximum information gain is order quantity. Is it simply a random guess or there is a theory? Yes, there is information gain that is calculated. Order quantity has the maximum information gain. Now if you take order quantity, we can split order quantity at a point which is 10, less than 10, greater than or equal to 10. Order quantity can be split at 15, less than 15, greater than or equal to 15, 2 segments. Order quantity can be split at 20, less than 20, greater than or equal to 20, 2 segments. Like that, there are so many splitting options. Decision tree will try all these splitting options, choose that splitting option which has maximum information gain, which gives us the purest segments, because there are so many splitting options. Exactly at what point if we split, we will get the best possible splits, we will get the best possible pure segments. Tell me, what is the splitting point within order quantity? What is the splitting point? What point is the exact point where we have to split to attain the maximum information gain? Are we going to split at 10 or 20 or 30 or 40 or 50 or 60? Look at that. Look at the output and tell me exactly at what point we have to split to attain the maximum information gain. Decision tree has decided, using formulas, it has decided that exactly at 40.5, less than or equal to 40.5, greater than 40.5, which means exactly if you split at 40.5, then you will get the maximum information gain. Since there are many splitting options, it has also found the best splitting point as well. This is like a condition that 40.5 order quantity less than or equal to 40.5 is like a filter condition. That filter condition is applied on top of those 11,805 records, these records. And that will give us the resultant 2 segments. By dividing the data based on that condition, we will get 2 segments. Let us see what are those 2 segments. Look at this, 11,805 records divided into 2 segments. First segment is the segment where order quantity less than or equal to 40.5. This condition, this is the true side. This is the false side. Usually in a tree diagram, left side is true, right side is false. So tell me, try to answer this question. Out of 11,805 records, How many records are having order quantity less than or equal to 40.5? How many records are having order quantity less than or equal to 40.5? How many records? First of all, have we already talked about what is 6408? Think about it. Have we already talked about what is 6408? 6408 is number of dissatisfied customers in 11,000 records. So the question is, out of 11,805 records, how many customers have order quantity less than 40.5? It's the population, this is the condition, this is the true side, which means 7397 customers have order quantity less than or equal to 40.5. So we can give a name to this segment. These are all the customers with order quantity less than or equal to 40.5. Okay. How many such customers are there? 7397. Out of them, how many are dissatisfied out of 7397? How many are dissatisfied out of 7397? 6374. Nearly 85% are dissatisfied. How many are satisfied? 1023. 15% are satisfied. Overall dissatisfied, in the overall level, full data level, dissatisfied was 55%, satisfied was 45%. Both mix of dissatisfied, satisfied are there. We made it into somewhat pure, 85-15. But is it the purest segment that we can get, or if there is a chance for further splitting, we should further split? Tell me, do we need to split or we should stop here? Is it the purest that we have achieved? If there's a scope, decision tree will actually further check. If there's a variable that has the maximum information gain on this subset, which can make it into further pure segments, it will do it. Apparently, decision tree has tried once again information gain of region, order quantity, customer type, and age. It has tried. Out of all these 4 variables, which variable has the highest information gain here on this subset? On this subset, which variable has the max information gain? Age is a variable that is having the maximum information gain. Now age can be split at multiple points. Age less than 10, more than 10, less than 20, more than 20, less than 30, more than 30. Like that, so many options are available. Precisely at what point we need to split to achieve maximum information gain? To attain maximum information gain, age need to be split at what point? 29.5. Out of 7397 customers, how many customers have age less than or equal to 29.5? Out of 7397, how many customers have age less than or equal to 29.5? Check that out carefully. Out of 7397, how many customers have age less than or equal to 29.5? This is like data. This is like condition. This is the true side. Always left hand side is 379 customers have age less than or equal to 29.5. Can we give a name to this segment? Name this segment. These are all the customers. These are all the customers. Can I simply say age less than or equal to 29.5? If I take all the customers whose age is less than or equal to 29.5, will I get only 379? We need to be little careful. These are all the customers whose, yes, order quantity, first condition is order quantity less than or equal to 40.5. Makes sense? Order quantity less than 40.5 and age is less than or equal to 29.5. Such customers are 379. Makes sense? Order quantity less than or equal to 40.5. Out of them, take age less than or equal to 29.5. You will get 379 customers. Out of them, how many are dissatisfied? 1% are dissatisfied. Around 99% are satisfied. Have we achieved pure segment, or do you think we should still push it for 100 and 0? Shall we still push it for 100 and 0, or we can stop it here, almost pure? This is like almost pure, isn't it? We can stop this here. Now we will be little fast. Give a name to this segment. Carefully, all of you participate. This is the kind of inference that you are going to do when you are working on practical projects. So give a name to this segment. This one. Name this. These are all the customers whose order quantity is less than or equal to 40.5. And is it and or or? And age is greater than 29.5. How many such customers are there? 7018. How many are dissatisfied? Always 0. 0 is dissatisfied. 91% are dissatisfied. 9% are satisfied. Come to this segment. We will quickly wrap this up. Tell me, what is the name of this set? Name this set. This 4408. Who are these guys? 4408 are those customers whose order quantity is greater than 40.5. Order quantity is greater than 40.5. Look at this. When I am writing this segment, have I defined age here? Is this really based on age or based on order quantity? Is 4408. Who are 4408? Is it order quantity greater than 40.5 and age less than 20.5? Is that the right answer? Think about it once again carefully. Are these the result of applying two conditions or only one condition? Think about it carefully. These are all the guys who are result of applying one condition on full data where order quantity is greater than 40.5. One condition, correct? Other than some are satisfied, some are dissatisfied. What about this one? If I come to here, then it makes sense. What about this one? This is order quantity greater than 40.5 and age less than or equal to 20.5. Most of them are satisfied, like that. We'll be writing. This will also take two conditions. That is how decision tree works. It takes the full data as input, 11,000 records. It gives us segment 1, 379, segment 2, 7018, segment 3, 475, segment 4, 34, 3933. These many records it will give us. That is the decision tree output. Now, this diagram is fine. But what precisely is the model building output? Let's say when you are building a machine learning model, let's say a client has given us a project. What is the final output a client is expecting from us? Be it regression model, be it logistic regression, be it decision tree. In general, machine learning projects, what is the final output that is expected out of you? Is it the Python code file that you need to submit as a final project? I'm done with this project. Is it the data set? Can we again, how order quantity threshold value is assigned as 40.5? At 40.5, we will have the maximum information gain. That's why. Let's say you can split order quantity at 10. So you can say one side segment is less than 10. The other side segment is greater than or equal to 10. That is one option. Order quantity. I can split order quantity at 10 if I want to. I can also make two segments based on 20, less than or equal to 20, greater than or equal to 20. Less than 30, greater than or equal to 30. Less than 40, greater than 40. Out of all these options, which option is most beneficial for me? Which one I should take? Think about it. If I have so many splitting options, where should I split? This will give me two segments. Either I can use those two segments. This will give me two segments. I can use alternatively this one. This will also give me two. This will also give me two. Out of all these options, which one we should use generally? The splitting option that gives us most pure segments, which means The splitting point where we have the high information gain. Apparently, decision tree will try all these splitting points 10, 15, 30, 40, 50, 60. Everywhere it will try all those splitting points, and after trying all those, it will give us that splitting point which has the max info gain. So in order quantity, where do you get the maximum information gain? According to the backend calculations, where do you get maximum information gain? Where? That is also given here. Where do we get it? 40.5. That's why 40.5 was decided. 40.5 is the splitting point. One side is less than or equal to 40.5, that is this side. Other side is more than 40.5, that is this side. Okay. But exactly at 40.5, so if I ask for the splitting point, exactly 40.5 is the splitting point. Here what they are showing is the condition. In the condition, we'll write less than or equal to and more than. Is it clear why 40.5 was taken? Yeah. The same way, age 29.5 was decided here. Here, the same value is not used. 20.5 is decided entirely depending on the information gain value calculation only. Nothing else. Let's take few more questions if there are any other questions on this. This is a little scattered. Let me take the clean one. Yeah. All right. So what I'm telling you is when you build a model, what is the final submission that you have to make? Is it the Python code file? Is it the data set that you have to give? Is it the predicted values that you need to produce? What is the final output of a machine learning model? The final output of a machine learning model is not the Python code file. Nobody cares what code you written. In fact, nobody cares which tool you have used. Doesn't really matter. It's not the data set. It's not the predicted values. It's not the data visualization. The final model is the model equation. If it is regression, you do whatever code you want, you do all those things. Finally, if you give this y equal to beta naught plus beta 1 x1 plus basically those beta values plus beta k xk, if you give me this, and if this is giving me accurate predictions, then I am through. Then I don't need anything else from you. Only thing is it has to give me accurate predictions. If you have taken care of all those model validation and all that, if it is giving me good accuracy, I'm happy with this. This final one equation. After 2-3 months of hard work, all things will boil down to simple one equation. That's it. If this one equation is giving me right predictions, if you are predicting sales, if I'm getting all right predictions, whatever you're predicting in the reality also, they are actually holding good. I don't care about what you have done in the background. Maybe internally in your team, while you are building this model, you may have a lot of graphs, you may have a lot of discussions, etc., etc. But at the end of the day, for a client, this equation does really matter. When we are building logistic regression, again that equation y equal to e power beta naught plus beta 1 x1 plus and so on plus beta k xk divided by 1 plus e power beta naught plus beta 1 x1 plus and so on plus beta k xk. This equation, this is the only equation that matters. It doesn't matter even if you have written 10,000 lines of code, it doesn't matter. If you give me this equation, this is sufficient. Specifically those beta values, beta coefficient values. When I was working for Citibank, in the credit risk models that we used to build, the final model used to be submitted as a map file, model approval process document we used to call. So after 3 months of hard work, we have a Word file which is just 2 pages long. That is the final submission. First page will be some discussion and the background about the model, so and so model. This is used for credit Citibank co-brand card with the Home Depot or something. And then the second page used to be variable x1. X1 means the variable name, EDW name, variable description. Finally, what really matters is beta coefficient. That's it. The second page table, that is the final model. If you have the table, if you have the coefficients, you can always create the equation. That is the model. That's it. Nobody cares about the code what we have written. But finally, these predictions have to be accurate. Like this is a final accurate model. This is a final product of the model. Similarly, is there any equation for decision tree? Because for decision tree, I can see only this diagram. So for a decision tree, the model is nothing but set of rules. Okay. For a decision tree, a model is nothing but set of rules. These rules come from the leaf nodes. For a decision tree, like the way in linear regression, you gave something. In logistician, you gave some output. For a decision tree model output, you have to give me set of rules. That will be your model. From there, I'll get the predictions. These rules come from the leaf nodes. Leaf node means terminal nodes. You have leaf node 1, leaf node 2, leaf node 3, and leaf node 4. So you are going to write rule number 1, rule number 2, rule number 3, rule number 4. Let me write down rule number 1. These rules are if then else kind of rules. If order quantity is less than or equal to 40.5 and age is less than or equal to 29.5, then the predicted value is satisfied or dissatisfied. If order quantity is less than or equal to 40.5 and age is less than or equal to 20.5, the predicted value is zeros, ones, satisfied. That is rule number 1. Some people write this rule, they forget what should be the predicted value. That is like a total disaster, isn't it? You have given the rule, but what should be the predicted value? Write down the second rule, all of you, associated with leaf node 2. Write down the second rule in the chat window. Rule number 2. If order quantity is less than or equal to 40.5 and age is greater than 29.5, then the predicted value should be dissatisfied. That is rule number 2. Write down rule number 3. Rule 3 coming out of leaf node 3. Rule 3 coming out of leaf node 3. If order quantity is greater than 40.5 and age is less than or equal to 20.5, such customers should be predicted as satisfied or dissatisfied. 0 dissatisfied, 1 satisfied. So I would say satisfied. Yes or no? If the last rule, if order quantity is greater than 40.5 and age is greater than 20.5, such customers should be predicted as again satisfied. Sometimes you can merge rule 3, rule 4, no matter what is the age, if order quantity is greater than 0.5, 40.5, satisfied, or even if you leave it as it is also is harmless. These are the 4 rules. These 4 rules put together is known as model, decision tree model. These 4 rules is decision tree model. Decision tree model is one of the easiest model to deploy on any platform, because deploying simply requires rules in a decision tree. That's it. You give the rules, you can simply deploy it on a website. You can deploy it on SQL server. All that you need to do is just simply give the rules. Automatically, the classification will happen. We don't need to really write these rules manually. There is a particular code. If we say export text, automatically order quantity less than 40.5, age less than 29.5, class 1 dissatisfied or satisfied. It will actually do this. Class 1 is satisfied for us. Class 0 is dissatisfied. Order quantity less than 40.5 and age greater than 29.5. This will anyway give us, but we are manually doing it to understand how these rules are generated. Once these rules are there, then your prediction can be done using these rules. Try to get the predictions for customer 1, customer 2, customer 3, customer 4. These are the new customers. I want you to apply a decision tree. Give me the predicted values, satisfied or dissatisfied for these customers. Satisfied or dissatisfied? First customer, C1. Give me the predictions, all of you. C1. By applying the rules, is the customer satisfied or dissatisfied? Customer number 1. Customer number 1, who has an order quantity of 20, who has an age of 70, he falls in here, dissatisfied. Customer number 2, who has an order quantity of 15, age of 15, he falls here, satisfied. Customer number 3 has an order quantity of 60, no matter what is the age, doesn't matter, age is 60, satisfied. Customer number 4, order quantity of 35, age of 55, C4 falls here, which means is dissatisfied. By applying the rules, we can get the predicted values. That is how you can build a decision tree model. Tell me one thing. Right after building a model, are we in a hurry to get the predicted values? Or, as a good habit, what we must do? Are we in a hurry to get the predicted values? Is that what is our next step of action? Yeah. Right after building the model, model building should be always followed by model validation, isn't it? If the model is good, then only I will be predicting. Then there is no point in building any random model. It will give you predictions, but how good, how bad are those predictions? Who will tell? Model validation is required. How good is my decision tree? How do you validate the tree? You have y actual values, which are zeros and ones. You have y predicted values given by the decision tree, which are also zeros and ones. When you have actuals, when you have predicted like this, how do you validate the model? What is the measure you will use? You have learned 2 validation measures, R squared, confusion matrix, and accuracy. Which one suits best here? For classification models, think about it. Is it R square and confusion matrix accuracy? Which one suits best here? For decision tree, for decision tree, you have y actual zeros and ones, y predicted zeros and ones. We have to create the confusion matrix, create the accuracy. So the concept of model validation for all the classification algorithms remains the same. You have y actual values. Earlier you get the y predicted values using logistic regression. But now you get the y predicted values using decision trees. You have y actual and y predicted. Then You create the confusion matrix, true positives, true negatives, false negatives, false positives. You get all those values. Go ahead, do the tree validation. Tell me how accurate your model is. The model that you have just built now, how accurate is that? To compare y actual, y predicted, you have, this is the confusion matrix. So you get all the predicted values. You have the y actual value. You have y predicted values. You have the confusion matrix. Find the overall sum, the sum of this column and this column, all the values. And CM00 plus CM11 divided by overall total, you will get the accuracy as 94%. So that only we should get into predictions because we got a pretty good decent model. That is our part 1 of the discussion of the decision tree. There are few more important points that I told you, right? And we have to discuss them. So there are few pointers that I have left. We are going to discuss them. But before going there, I would like to take the questions from you. Any questions, anybody? All right. If there are no questions, I think after this much of discussion, we need a quick tea. So let us take a break. Let's meet at 3:30 p.m. and then we are going to continue the discussion on these decision trees. Okay. Once again, quickly before getting into the tea, are there any questions that I need to address? Quickly. All right. So let's meet after the tea and then I'll take few more questions. Then we'll go to the next topic discussion. Welcome back, everyone. Once you're back at your desk, send me a message. All right. Until now, we discussed building a decision tree model and validating it. Let's take a fresh scenario. Let us suppose you have a data set. Imagine, say you have, let's say, 20,000 records. There are 20,000 records in that data set. There are certain columns, features, and you have the target variable y, 0 and 1, 0 and 1. These are the values it takes. There are some zeros, there are some ones, like this. Target variable takes values like this. Let's say we start building the decision tree model. We started with this. There are 20,000 records here. We use the variable that has the maximum information and split it into two parts. Let's say 6,000 records are here, 14,000 records are here. We are further splitting it. Let's say there are 5,000 records here, there are 1,000 records here, there are some records, some records. Again, we started further splitting it. Further split. Let's say out of the 1,000 records, there are, let's say, around 150 records are here, 850 are here. We should have stopped this process at one point when there is not much of improvement in the entropy, which means when there is not much of reduction in the entropy, we should have stopped it. What if we do not stop it? What if I want to build a very large tree? Even though there is a very less improvement in the entropy, still I kept on growing this. These 150 records also I have divided into two parts. Let's say there are 140 records here, 10 records here. This is also divided further. This is also divided further, like that. Everywhere I kept on growing the tree. Even though there is a very less information gain, still I kept on growing these 10 records also. I started growing it to 2 records here, 8 records here. If I keep on growing like this, is there any hard stopping point where this tree will stop? Or I'm just wondering, is this tree going to go infinitely long? That's what I'm thinking. Is there a point where this tree has to stop? Out of these two records, if I further divide it, they'll be divided into one record and one record. Once you have a node, once you have a leaf node, there is only one record inside it. Is it possible for dividing this one record into further into two records? This record, can we make it into two subsets? There's only one customer here. Can we make him into two subsets? Is it possible if there's only one record here? Can we make it into two subsets? No, there is a hard stopping point. What is the hard stopping point? If a leaf node contains only one record, if a leaf node contains only one record, that leaf node cannot be split further. That means overall, if you have n records, and if you have one leaf node containing one record, what is the largest decision tree that you can have? How many leaves will be there in the largest decision tree that you can think of? Largest decision tree will have how many leaves? Maximum number of leaves that you may find. One leaf node will have one record. Overall n records are there. you will have finally n leaf nodes. The largest tree that you can have will have n leaf nodes because each leaf node will have one record. One leaf node gives us one rule. One leaf is giving us one rule, which means here the largest tree will give how many rules? On a data set which has n records, the largest tree will give how many rules? Here we have 20,000 records. So for this data, how many rules you will get? Finally, the largest tree. If I build the really largest tree, the number of rules that you will get out of this decision tree would be maximum. The upper limit will be how much? If I build the largest tree, it will have n leaf nodes. The largest tree can have n rules. N is here 20,000. Here it is 20,000 rules in this particular problem statement. You have a data set which has 20,000 rows, which gives rise 20,000 rules. What the hell? We built a model which is taking 20,000 rows as input. In return, it is giving 20,000 segments as the output. 20,000 rules, 20,000 segments as the output. Each segment has only one record. If you look at this result, you will be surprised to see that the first record will be your first segment or first rule. The first rule will be if x1 is this much, x2 is this much, x3 is this much, xk is this much, whatever is the y actual value that you see here, that will be given as y predicted. That will be the rule. The second segment will be second record, or the second rule will be if x1 is this much, x2 is this much, x3 is this much, whatever is the second row, that will be your second rule, and whatever is y actual, that will be your y predicted. Like that, you have 20,000 rows, you have 20,000 rules. Each row becomes a rule. One row will become one rule. And the predicted values will be whatever are the actual values. In that particular row, what is the actual value? That will be predicted value. Look at this decision tree. Are we really building any model here? Is it learning any patterns? Or is it simply memorizing the data, giving back the data? Here we took the data in the horizontal format or this vertical format and then arranging it in the tree. In the name of rules, what are we giving back? In the name of 20,000 rules, what am I giving back? I'm giving back the data only, isn't it? 20,000 rows I'm giving, isn't it? In the name of 20,000 rules, I'm giving the 20,000 rows back. Are we really learning anything? Is this model really learning anything? Or is it simply giving back the data? Think about it. Is this model learning anything? This model is not really learning anything. It just takes the data as input. In the name of rules, it is returning us the data. Point 1. Point number 2. That itself is a kind of blunder. On top of it, if I calculate the accuracy for this model, if I create the confusion matrix, compare y actual versus y predicted, look at zeros, zeros, ones, ones. What will be the accuracy of the model if I calculate accuracy? How much will I get? If I create confusion matrix and calculate accuracy, how much will I get? Look at that carefully, think about it. Carefully think and let me know. Wherever is the actual value, it is matching with the predicted value. Wherever there are actual values and predicted values are almost equal. Look at this. First row actual and predicted matching. Second row actual predicted matching. Third row actual predicted matching. If everywhere actual and predicted are matching, what will be the accuracy of a model? Everywhere actual and predicted are matching, the accuracy of this model will be 100%. So here we go. If you build a largest model, if you build a really large model with 20,000 rows, if you are building 20,000 rules, the accuracy of that model will be 100%. Okay. Now, is this a really good model? Is this a really a good scenario to be in? One side we are saying that we did not learn anything. On the other side, we are saying that the model is 100% accurate. There is something wrong that is going on, isn't it? Yes or no? Let us see what is it. Here, we need to understand another concept. The data set that is used for building the model, the data set that you have here, those 20,000 records are here. This is the data set that is used for building the model. This data set is known as train data. A data set that is used for building the model is known as train data. Usually we have to keep aside another data set that is used for testing the robustness of the model. The model that you have built, whether it is good or not, that is known as test data, which is kept aside, which is never exposed to the model. Both train data, test data come from the same population. They represent the same data. But this is exposed to the model. While building, we gave this data for the model to understand the patterns. After building the model, we validate. If it gives a good accuracy, we are happy. But sometimes we may have to cross-validate. You check whether this is doing a good job on the test data as well. There are some cases if the model is kind of memorizing the data rather than finding the patterns in the data. If it is memorizing the data, then model may show very high accuracy on trained data, nearly 98% accuracy, 99% accuracy, 100% accuracy on the trained data. Shows significantly lower accuracy on the test data. Then these models are not preferred because they will work only on this trained data. If I change the data slightly, the model fails utterly, and I am not building the model to apply on this data. I am building the model to apply on future records. I am building the model to get the predictions on the future. Obviously, the model will fail utterly in future as well because it failed on test data. Test is the representation of my future. So in model building, especially in decision trees, this is a very big problem. This problem is known as the problem of overfitting. Very critical concept, especially in decision trees. Decision trees are very vulnerable. Decision trees suffer from a problem of overfitting. What is overfitting? The model works really well on the trained data. It gives very high accuracy. High accuracy on trained data, 99%, 98%, 100% accuracy on the trained data. Significantly low accuracy on test data, 60%, 70%, 65%. These type of models are known as overfitted models. They work only on this trained data, they fail everywhere else. Usually you have only one data set, okay? Usually you have only one data set which is known as overall data, that's it. You don't have two data sets. You shuffle this data, okay? After that, take 80% of this data. Take 80% of this data, use it for model building. Call it as trained data. Act as if you never got access to this remaining 20%. Keep it aside. Use it for cost validation. Use it as test data. That's what we must do. There are already functions for splitting this data into two parts. Otherwise, this is simple sampling. We can take 80% of the data, build the model on it, keep the rest of the 20% for the cross validation. Especially decision trees are very vulnerable. If the decision tree is really large in size, if we are building a large decision tree, then we may get into the problem of overfitting. Once again, what is overfitting? One of the most widely asked interview question. A very critical concept. What is overfitting? The model works very well on the trained data, the data set that is used for building the model. The model fails miserably on the test data. Until now, I have not introduced the concept of test data set for you because the rest of the algorithms are not that vulnerable. Linear regression, fine, works. Logistic, fine, works. But decision trees, nope. Very strict. We need to have trained data as well as test data. Build the model on trained data, validate, well and good. Cross validation is also required. So when it comes to models from here on, not only decision trees, let us have that rule for every model. For every model, you build the model, you validate, on train data first, and then you cross validate and check whether it is working equally effectively on the test data as well. That is a rule that we are going to follow from here on. Sometimes the model shows very high accuracy on train, significantly low accuracy on test. Those models are known as overfitted models. Let us see how does overfitted models appear. Take this data set, train data as well as test data, build a model on train data, cross validate it on test data, tell me the accuracy on train data, tell me the accuracy on test data. The accuracy on the train data, how much have you got? Train accuracy, 100%. If the train accuracy is 100%, is it the time to celebrate? Can we be really happy? Is it the world's best model? Can we think like that? No. We have to cross validate it on the test data. If the accuracy on the train data is 100%, how much accuracy is expected on the test data? If the model is good, robust, if it is true accuracy, how much accuracy is expected on the test data? 100%? Yes or no? Agreed or not? Or if there is a little bit of change, what is accepted? Usually how much difference is accepted? 99. Is it accepted? Or 98? Or 97? What is the significant difference usually in business? When do I say there is a significant difference? How many points difference is called a significant difference? Tell me, try to recollect. When you are comparing two things in general business, when you are comparing two percentages, how many points difference is considered as significant across all the industries? Try to recollect. Any difference of 5 points or more, have we discussed it? Any difference of 5 points or more, that means if train accuracy is 95, at least you want to have a test accuracy of 95%. If train accuracy is 100, test accuracy must be 95 or above. So test accuracy has to be either 96 or 97 or 98, at least 96 it should be. Anything more than that, it's a clear case of overfitting. So what is the accuracy on the test data that you got? You should get 96%. How much is the accuracy on the test data you got? Instead of 96, I got how much? 16%. Is it acceptable? Is it okay to let it go? ठीक है यार 96 के so like instead of 96 I got 16. क्या है? Is it okay like that? No, right? Even if it would have been 95 or 94, we would have let it go. But this is 16%. This is a clear case of overfitting. Overfitting in decision trees happen due to large trees. If the tree is too large, then overfitting happens in decision trees. That is why, as a data scientist, if you are growing the decision trees, it's also our responsibility to cut short the decision trees. It is known as growing the trees. Opposite of it is pruning the trees. As a data scientist, we must prune the decision trees. This process is known as pruning. Pruning is done by using pruning parameters. So we need to cut the trees, decision trees only, not the general trees. Pruning is used for cutting down the decision trees. Otherwise, the decision trees are very much prone to overfitting. Yeah. Can you explain the previous part again? What is the previous part? This one you meant to say? Sure. Yeah, you have any specific question in this? I'll try to focus on that.
Last part, the trains and the test data, that 9600%.
Yeah. So let us try to have a dialogue, then it will be easy. What is the accuracy on the train data? So have you done this exercise?
Yeah,
In this
it's one.
exercise,
It's
how
one.
much is the accuracy?
It's
100%, isn't it?
100%. Yeah.
100% is accuracy. If this model is robust and train data and test data are coming from the same population, what is the expected accuracy on the test data if I apply the same model? It's giving me 100% accuracy on train data. What is the expected accuracy on test data?
100%.
100%. Okay, I can expect the test data is not same as train data. So we can give some leverage and we can say 99 is also fine, isn't it?
Yeah.
Or okay, 98 is also fine. Or okay, 97 is fine. But when do I start considering there is a serious gap? At least if it
5%.
is above 95, until there I would say it's okay. I can
Okay.
expect 5%. But if it is way less than that, then I can say this is not just due to randomness, this difference. There must be something wrong with the model. Fair enough, isn't it?
Yeah.
1 or 2 point difference, 3 point difference, 4 point difference, until 5 point difference, it is considered as fine. Anything more than that is considered as a significant difference. But when we applied this model on the test data, how much is the accuracy that we got in the output? You will have it. How much?
0.1.
0.16, isn't it?
Yeah.
We convert to percentage, it will be 16%,
Yeah.
isn't it? Accuracy on train data is 100%, accuracy on the test data is 16%. Definitely, this is a clear case of if I have 100% accuracy on train, 16% accuracy on test, this model is suffering from the problem of
Overfitting.
overfitting. Overfitting in the decision trees happens due to if you are building a decision tree, your decision tree is overfitted because if the tree is
Large.
too large. If the tree is too large, then overfitting happens. That is why while building the decision trees, we need to do something called pruning.
Yeah.
Pruning means cutting down the decision trees, not allowing the tree to grow too large, larger than whatever is required. Pruning is done using pruning parameters. Let us see what are the pruning parameters. But before that, let me just wait here. Any other connected questions anyone has quickly? Let us clarify them before going to pruning. Any other connected questions? All right. Pruning is done by using pruning parameters. One of the pruning parameter is max depth. Max depth is a pruning parameter. If you take this decision tree, this is a decision tree with depth 1. If you take this decision tree, this is a tree with depth 2. This is a tree with depth 3. At depth 3, how many leaf nodes are there? Can you make a guess? At depth 3. If I take depth 1, the leaf nodes will be 2. If I go depth 2, how many leaf nodes are there? At depth 2, how many leaves will be there maximum? 4. At depth 3, how many leaf nodes will be there? Each of these 4 will give 2, 2, 2, 2 more. Which means at depth 3, how many leaf nodes will be there? 8. Similarly, can you try to make a guess at depth 4, how many leaf nodes will be there? Each of these 8 will give 2, 2, 2, 2 more. 16. At depth 1, 2 power 1 leaf nodes are there. At depth 2, you have 2 square leaf. At depth 3, 2 cube, 2 power 4. Which means at depth 5, how many? 2 power 5, 32 max leaf nodes will be there. By giving the max depth, you can control the growth of the tree. Let me show you how. For example, you have 1 million records. Suppose that you have 1 million records, large data set. If you want to overfit it, you nearly required 1 million leaf nodes, isn't it? So that you can learn each and every rule, each and every row as rule. Almost 1 million rules are required. But while building this model, I gave max depth equal to 4 only. While building the model on this data, I gave max depth equal to 4 only. Maximum how many leaf nodes will be there in that case? While building this model, I have set max depth as 4 only. In that case, how many leaf nodes will be there in the resultant model? Only 16 leaf nodes will be there. 16 leaf nodes will give you how many rules? From 16 leaf nodes, how many rules you will get? Each leaf node gives me one rule. 16 rules you will get. Is it possible for us to use 16 rules to memorize almost 1 million records? To memorize 1 million records, you require 1 million rules. But by using 16 rules, can you overfeed these 1 million records with just 16 rules? Is it possible? Usually it is not that easy to memorize all these records within just 16 rules. That is how you can avoid the overfitting by pruning, by not allowing this tree to grow really large, by cutting down the tree is known as pruning. One of the pruning parameters is max depth, which will stop the growth of the tree. This is used for avoiding the overfitting. This is one of the pruning parameter. There is another related pruning parameter. The second one is connected to this only, max leaf nodes. This is another pruning parameter. Either you can give max depth, alternatively you can work with leaf nodes as well. Indirectly giving max leaf nodes is same as giving max depth only. Let's say while building the model I told max leaf nodes is 8. I did not use max depth, but I told max leaf nodes is 8. Indirectly what did I give? Tell me to the model. Indirectly in terms of depth, what I have mentioned, if when I tell max leaf nodes is 8, I have mentioned the depth of 3. Indirectly, if I would have given max leaf nodes equal to around 64, indirectly what I have mentioned in terms of depth, max leaf nodes is 64. Indirectly what I have mentioned, so 2 power 6 will be what? 2 power 6 will be 32, 64. So max depth I have mentioned as 6. Either you can give max depth or you can give max leaf nodes. Both of them are interconnected. You don't need to use both of them. One of them is sufficient. Both of these are known as pruning parameters. These pruning parameters, max depth and max leaf nodes, they will help you to stop the growth of the decision tree. If you stop the growth of the decision tree will avoid overfitting. Decision trees are prone to overfit easily. It is our responsibility. By mentioning these pruning parameters, we have to avoid overfitting. However, these pruning parameters are like double-edged swords. We need to be little careful. Let me tell you some of the practical issues when you are using pruning parameters. For example, you have a data set which has 1 million rows. And you have good number of columns, x1, x2 and so on, 50 columns, very rich data, pretty good data. It can give you very good accuracy. Nice patterns are there in this data. But we are scared of overfitting. So what did I do while building this model? I gave max depth equal to 1 only. For this huge rich data with 1 million rows and 50 columns, I mentioned max depth equal to 1 only. And how many leaves will be there in this tree finally? Since there are 1 million records, can I have 4 leaves, 5 leaves? Will this tree be a very big tree or it will be a very smallest tree? Think about it. That is it. This is the end of the tree. No matter what data I have, only one variable will be here, isn't it? And that is it, end of the tree. Agreed or not? Can I have more than 2 leaf nodes? Think about it. I gave max depth equal to 1. Can I have 4 leaf nodes? Is it possible? Since the data has so many patterns, will the tree grow further? Yeah, it will be like 1. What is it? Just simple 2 leaf nodes are there, that's it. What is the risk here? I have a very rich data set with a lot of columns, but still I built a very small tree. What is the risk of building very small trees? Think about it. Very small tree. What is the risk here? Is there any problem or is it okay? Does it sound okay to you? Does it sound okay to you? Is there any problem here? What do you think? Think about it. Everybody, try to think about it. Is it okay? Do you see any problem? Try to phrase whatever you're thinking. Try to tell me like what is the issue here? What kind of issue that you see if you're building a very small tree? If you're building a very small tree, what can happen? What can happen here? Is it okay? Can I go ahead and approve these kind of models? Somebody is saying data loss. That means the information loss. That means the model is not good enough. Yeah. We can't segment to derive at any value of y output prediction. Accuracy might decrease. Accuracy may be low. What accuracy are you talking about? Accuracy on trained data itself. The data set that is used for building the model. Accuracy on trained data itself is very low. Agreed or not? That was the result. That was a comment given by somebody. Accuracy on the trained data itself would be very low. That means on the trained data itself, I have seen 60%, 50% or 65% accuracy on the trained data. How can I expect higher accuracy on test data if the model is not even learning well on the trained data? Accuracy on trained data itself will be low. Definitely on the test data, it will be even lower. If the tree is too small, then you will get into a problem of underfitting. Underfitting is also a problem. What is underfitting? Accuracy on trained data, the data set that is used for building the model, that itself is low. Something like 65%, 55%, 50%, 60% or 70% accuracy. There is a scope for improvement, but we stopped too early. We gave up too early. There are so many patterns, but we gave up too early. When it comes to underfitting, you don't even need to look at the test data accuracy because on the trained data itself is very low. There's no point in verifying it, cross-validating it. The model is not good on the data set that is used for building the model. From where it will show higher accuracy on the test data? No. What is overfitting? Once again, what is overfitting? Overfitting. What do you observe in overfitting? Accuracy on trained data is high. Accuracy on trained data is high. It will be like 90%, 98%, 100%, something like that. But when you apply the model, accuracy on test data is significantly low, which is like 60%, 70%, 50%, like that. That is overfitting. What is underfitting? What is underfitting? Accuracy on train itself is very low, 60, 50, 65, like that. Accuracy on train itself is low. Don't worry about the test. This model is not even good on the train data. When does overfitting happen in decision trees? If the tree is too large. When does underfitting happen in decision trees? If the tree is, when does underfitting happen? If the tree is too small. So a tree neither should be too large nor should be too small. The tree has to be of optimal size. The tree has to be optimal size. If the tree is too large, then you will have the problem of overfitting. Model is not useful. If the tree is too small, model is not useful. Underfitting will happen. Overfitting is also a problem. Underfitting is also a problem. Tree has to be of optimal size. How do you decide the optimal size of the tree? Let's say max depth has to be optimal. How do you know the max depth optimal value? This max depth optimal value, just by looking at the data set, we will not get to know. In fact, nobody, no matter how great a data scientist one can be, by looking at the data set, nobody will tell us what is the optimal max depth. This needs to be discovered. We have to try 2-3 iterations and then discover it. So follow this process to find the optimal max depth. Suppose that you have a data set, large data or small data, whatever data that you have. And all of us, we don't know what is optimal max depth. Nobody knows. Then how do you find out what is optimal? Here is the process. Let's say you have 1 million records. Obviously, this is a serious problem. We don't know what is the optimal max depth. It can be 4, it can be 5, it can be 10, it can be 20, it can be any number. What is the optimal max depth? To decide that, you know what you should do? First, intentionally build a very small tree. Choose max depth equal to 1 only. Let's call that as model 1. Model 1, you choose max depth equal to 1. Invariably, what will happen to this model? If you are choosing max depth only 1, invariably, most often, what will happen to this model? It will be a very small tree. It will give you very low accuracy. Technically, what is the name of that? If the tree is small, if it is giving you low accuracy, this is suffering from the problem of this model. M1 would be, try to participate everyone. If you are building a small tree, this will be an underfitted model. If a model is underfitted, with depth 1 it is underfitted. What is our next plan of action? We have to increase the depth. We have to make the tree slightly bigger. What I suggest is, don't take 2 or 3 or 4 or 5. Don't take anything nearby. Take a very large number. The number that you can think of. Maybe take 20 or 30. Max depth is 30. Can you make a guess at max depth 30? How many leaf nodes are expected? Is there a formula? At max depth 30, how many leaf nodes can be seen? How many are we giving as a scope? If you choose depth as 30, 2 power 30. Is 2 power 30 a large number or a very small number? 2 to the power of 30, such a large number. You are giving too many leaf nodes. So this is model M2, which is a very big tree. Invariably, what will happen to model M2? Invariably, if you are building a very large tree, this will be overfitted. Now you have tried 2 models. Model 1 underfitted, model 2 overfitted. What is the next plan of action? You have to try max depth with a different configuration. Can you suggest the number that I should try next? Carefully think, what is the smartest number that we should try next? What is the smartest number? Usually, if 30 is overfitting, 1 is underfitting, what we should take? Right in between these two, something like 15. Try max depth 15. Imagine at 15, your train accuracy is, let's say, 95%. Your test accuracy, let's say, 60%. Shall we finalize this model, or shall we go for one more iteration? What's the problem here? This model M3, can we finalize this? M3 is overfitted. What is our next plan of action? Shall I try max depth as a number between 15 to 30, or shall I try as a number between 1 to 15? What is our next plan of action? Model M4 will be with which configuration? Since it is overfitted at 15, I can totally ignore all this. Think binary. So number between 1 and 15, something like 7 or 8. Let's say you have picked 8 as the max depth. This is model M4. Let's say your train accuracy is 90%. Test accuracy is around 78%. Can we finalize this model, or do we need to run one more iteration? Can we finalize this model? No, this is still overfitted. What's the number that you're going to try next? What's the number? Somewhere between 1 and 8. This is a M5 model. Let's say I'm taking the depth as 4. Let's say for this M5 model, the train accuracy is around 86%. Test accuracy is around 85%. Can I finalize this model or shall I go for one more iteration? Shall I finalize this model? Is it okay? 1 or 2% difference? Is it acceptable? So optimal depth of this particular model, it took us 5 iterations to arrive at it. Optimal depth is 4. Usually, if 4 is the optimal value, you may tend to get similar results for depth 3, depth 5. Usually, the optimal values are a range of values. Range of values. What you need to do is get nearby that range of values, then you'll have the good model. 4, 5, 3. Usually, the nearby values tend to give the same results. That is how you have to discover what is the optimal depth. Sometimes it may take 2-3 iterations. Sometimes within 1 shot or 2 shots you may get the optimal value. However, by looking at the data we will not get to know. For someone else optimal depth may be 5. For me that may be overfitted. For some other problem 5 may be underfitted. We cannot take the standard values. Anybody can build a model, but the person who knows what is this max depth doing, how to fine tune this, when to increase, when to decrease, then only we will be able to build the right decision trees. Apart from max depth, what else I can try instead of max depth? Is there any other option? Instead of fine tuning max depth, what is other pruning parameter? Max leaf nodes. So if we go to the decision tree code, while building the decision tree, this is the place, tree.decision tree classifier. Here, either we can give max depth or we can give max leaf nodes if required. If we do not give it, if we leave it as blank, what do you think Python going to assume it as default value? Is it going to take max depth default by 1? Is it going to take max depth default by infinity? Is it going to find the optimal value and build the tree? What do you think it's going to do? Can you make a guess? Python is going to take 1 as default, build a short tree. Is going to take infinity, countably infinite as default, build a large tree. Or is it's a good friend of ours? It will give us the optimal value on its own. What do you think? If you don't mention any max depth, it's not going to build a small tree for sure. It's not a very good friend of ours. It's not give us the optimal value either. By default value of max depth is countably infinite. That means by default, if you don't mention max depth, what kind of tree can be expected? Infinitely large tree, very big tree. That means it will be overfitted. Have you seen it? Train accuracy 100%, test accuracy 16%, overfitted. Similarly, max leaf nodes, if you don't mention anything here, what's the default value? Is it 2 leaf nodes? Is it countably infinite leaf nodes? Or is it optimal value? What is the default value? It's not 2. It's not optimal. Countably infinite is the default value, which means if you don't mention max depth, if you don't mention max leaf nodes, if you leave the tree as it is, what will be the resultant tree? If you leave the tree to default values, always your resultant decision tree will be overfitted without any doubt. What you need to do is either you give max leaf nodes or max depth to fine tune it. What I want you to do is, let me not help you. For this particular problem, right now it is overfitted. Can you fix it? Can you fix the issue here? Fix the issue. What I want you to do is go with max leaf nodes. Go with max leaf nodes. Try max leaf nodes. And then what are the optimal max leaf nodes? Sometimes a range of values are optimal. At that optimal values, what is the train accuracy? What is the test accuracy? Go ahead, fix this issue. Give max leaf nodes. Yeah. What is optimal value? Number of leaf nodes, what is optimal? So 3 is the answer some people gave. Usually if 3 is the answer, I may guess maybe 2 gives right answer sometimes. Sometimes even 4 also gives right answer. But you have to verify and check whether which one of them are correct answers. At that point, train accuracy is 85. Test accuracy is 83. Is this fine? 85, 83, that gap is fine. Usually gap of 2-3% is not a big deal. 1 or 2% is not a big deal. That is the max leaf nodes. What is the optimal value? Either 2 or 3. Both of them give the same result. Yeah. Similarly, delete max leaf nodes, include max depth and try to fine tune this. Tell me the optimal values from the max depth point of view. From the max depth point of view. Tell me the optimal values, depth. Whether you do leaf nodes or depth, the train accuracy, test accuracy, they should not change. So train accuracy will still be 85 in the result. Test accuracy will still be 83 in the result. Max depth, what are the optimal values? What are the optimal values? People are saying 2. Sometimes if 2 is right answer, you may get 1, 2, 3. They may give you right answers as well. But we have to check whether all of them are right answer. Usually range of values are the optimal if you have to be near the range. Is the 3 depth also working or it's overfitting? Can somebody confirm that? Depth of 3 is overfitting. So 1 or 2 is the right answer. That's how you have to fine tune these pruning parameters or the hyperparameters. If you leave it to default values, always the model will overfit. This is the optimal model. Either you fix max leaf nodes or you fix max depth. Doesn't matter. Any one of these two you have to use. If you are understanding the fact that if you are increasing the max depth while you are fine tuning this, if you are carefully detecting the overfitting, then you are through. Because underfitting generally we don't do it. We don't settle for the less accurate models. If the model accuracy is 40%, hardly anybody will finalize it. Overfitting is the bigger trap that we always fall into. So we have to avoid overfitting by mentioning these pruning parameters. Okay. Any questions on this pruning? Will you be able to detect overfitting and do the pruning on your own? Will you be able to fine tune? Have you done it on your own, everyone here in this exercise? If you have done it on your own and if you have got the result, in future also for any data set, you must be able to do it. Any questions on this? Anybody? Any questions?
So to test underfitting, we just have to check the accuracy of the trained data, is it?
Correct, yes. If the
Okay.
trained data itself is having low accuracy, then we can say it is underfitted. A
Okay.
safe bet would be always overfit the model first, okay, when we
Okay.
are in doubt, and try to come from the top to bottom, like slowly reduce the gap between train and test data.
Okay. Yeah, got it. Yeah, thanks.
I'm going to write down the steps in building the decision tree model, but before there, we are going to take few more questions. Max depth of 1 or 2 max leaf nodes are 2 or 3, giving same results. But if I give max depth of 2, that gave 4 nodes, which won't give me optimal results? Very good question. Look at this decision tree and tell me what is the depth of this decision tree. What is the depth of this decision tree? Check that carefully, or let me write it slightly neatly. I will draw it. This is the decision tree. What is the depth of this decision tree? The depth of this decision tree is 2. Depth equal to 2. At 2 depth, you have 4 leaf nodes. Maximum you can have 4 leaf nodes. But what I have observed is there is a purity that has been achieved here. This got stopped. But the purity was not achieved here, so it went on to here. What is the depth of this decision tree here right now? This decision tree depth is also 2. But at depth 2, how many leaf nodes are here? There are leaf node 1, leaf node 2, leaf node 3. So sometimes even at a larger depth, you may have lesser number of leaf nodes. Let's say in here, if I do it like this depth will be 3, 1, 2, 3. But still, the number of leaf nodes that I have are 1, 2, 3, 4 only. Okay. This is not a leaf anymore. Leaf is a terminal one. 1, 2, 3, 4 leaf nodes are. So that's the reason why. So exactly max depth 2 is not converting it into leaf nodes 4. So that's the reason why there is a discrepancy. So max depth 2 is entirely not equal to always max leaf nodes 4. Sometimes leaf nodes can be 3 only at depth 2. That's why. Make sense? That's right. Any other connected questions? So it would be best to give max depth than max leaf nodes? Not like that. Like either we can play with max leaf nodes or we can play with max depth. There is no additional benefit of using any one of these two. Both of them work the same way for most of the problems. Step number 1, after deciding the objective, after data cleaning, data exploration, validation, etc., when we decide that it's a customer segmentation problem, we have to use a decision tree. Once we decide that, the step starts. Step number 1, take the overall data, divide it into 2 parts, call them as train data and test data. Usually, what percent of the data is considered as the train data? How much portion usually? Usually 80% of the data is considered as train data. 20% of the data is considered as test data. Sometimes some people take 75, 25, that's also fine. But large portion for training, considerable portion for testing. As usual, build the decision tree model by using all features. Right after building the model, what we should do? Building the model should be always followed by model validation. Here model validation has 2 parts. Part 1 would be validate the model on the train data, get the train accuracy. Cross validate the model on the test data, get the test accuracy. While building the model, if you leave it to default parameters, so decision trees are very vulnerable. There is one problem that they always face when you leave the model to default parameters. Decision tree models are very prone to decision trees are very much vulnerable. They are always prone to overfit. That means train accuracy will be very high, test accuracy will be significantly lower. To avoid overfitting, We follow a certain process. What is the process of avoiding overfitting? What is that called? Pruning. Pruning is performed by mentioning pruning parameters. Tell me the pruning parameters. Tell me one of the pruning parameter. Max depth. Do you think max depth should be very high or very low or optimal? What do you think? Max depth. Is it good to have a very high number? Is it good to have a lower number? No, it has to be a optimal value. If you leave it to default value, what will happen? If I leave max depth to default, what will happen? What is the default value? Countably infinite. Or you can also play with max leaf nodes. Similarly, the default value of max leaf nodes is that's also countably infinite. It has to be neither very high nor too low. It has to be optimal. Then when do you finalize the model? You fine tune all this, finalize the model when we have to run some iterations when we see highest accuracy on train data, along with it highest accuracy on train data and matching accuracy from test data. Once we have the highest accuracy on train data, underfitting is taken care of, and it is matching with the test data, overfitting is also taken care of. These are the steps you are expected to follow when you are building a customer segmentation model. Maybe in future, if you are working on segmentation techniques, one thing that I want to really highlight here is the process of pruning. If you have understood this whole concept of pruning, what these max depth, what these max leaf nodes are doing, then you can comfortably build the decision tree models in future. That's the only complex thing. That is the story of decision trees. These are customer segmentation algorithms. They also fall under classification, but customer segmentation, if that is a problem statement, dividing the customers into different groups, especially used in marketing. At those places, we will be preferring, so let's say sales segmentation, okay, marketing segmentation, and insurance segmentation. Divide the customers into different groups, set a particular premium for a particular group. All those, wherever there is a segmentation, operation segmentation, wherever there is a customer segmentation coming into the picture, decision trees are preferred. That is the story of decision tree. Any questions on this, anybody? Has anyone worked on decision tree earlier? Is there any important point that we have missed, or is there any question from the project? That also you can ask here. We can discuss the answer. Well, that is it for today. If you have any questions, you can stay back. Otherwise, you can drop off. Once again, thank you very much for the chat. We'll keep the same enthusiasm for one more day. Tomorrow, again, interesting algorithms have lined up, interesting case studies, somewhat complex algorithms, but very interesting to learn. Tomorrow, we'll meet at 9:30 a.m. Thank you, everyone.